Good morning. It is 8:30 in the central time zone. And for those of you joining remotely from the rest of the country, it's 30 minutes after the hour, wherever you are. And we're going to get going. As I mentioned to this group already, my name is Brian Hurt, and I am with CTC and Associates. And we are under contract with the Minnesota DOT to help with communication and facilitation of this pool fund. This is my first chance to actually meet this group in person. This was my first chance yesterday to actually meet Kyle in person for the first time. Some of the others of you I've met at the TRB meeting and elsewhere. Really glad to be here. Enough about me. This is Kyle's and your team's meeting. I'm going to be assisting with facilitation and keeping us moving along and keeping us on track, and assisting with some of the development of documents as we get into the heart of the meeting. With that, I'm going to actually turn it over to Kyle pretty quickly here, and you'll be hearing more from me in a little bit. So let's go for it, Kyle.
Sounds good to me. So first of all, thanks to everyone for showing up. It's a good turnout because we have such a great program, right? With DPS. That's why you all showed up. And I guess the only thing I'll say before we get into introductions is this could be potentially a really, really boring meeting. Or it could be a very fun and interactive meeting. And that depends on both this group that's here and the people who are joining online. Kind of the only way this meeting is going to be useful is if the group is willing to share thoughts, positive and negative, as part of this meeting. So with that, I think let's go around the room and introduce ourselves. I'm Kyle Hoig with MnDOT Research. I'm a program manager for the DPS Pooled Fund. And with that, I'll turn it over to Mercedes.
I'm Mercedes Kuznia with MnDOT, research scientist with Kyle.
And I'm Steve Cooper with Federal Highway, the Resource Center, working with Kyle a long time on it.
Rob Hinman, Federal Highway from the Ohio Division Pavement Materials Engineer. And involved with non-destructive testing and GPR and DPS for a while.
You hearing everybody okay?
Tom, you Federal Highway Administration, the pavement design engineer.
I'm Pete Ekman with the Federal Highway Administration, Minnesota Division Pavement Materials Engineer.
Sean Tagai, Research Operations Engineer at MnDOT. Work with Kyle Mercedes on the DPS study. Want to welcome everybody come to this meeting and appreciate the continued support and the participation in the project. My view is very successful.
Brett Traum, Missouri DOT Physical Laboratory Director.
Joe Sias, University of New Hampshire.
Mike Copeland, Federal Transportation Department, Quality Program Manager for Construction. Brendan Rock, New York State DOT Materials Engineering Bureau. Jay Walker, DOT Office of Materials.
Department of Transportation, pavement sections.
Rick Johnson, Minnesota DOT pavement section also.
I see, page B, from Michigan Tech.
Can't hear it.
Federal Watson, also
One second. People online, could you hear any of the introductions?
Not clearly.
Okay.
It's not loud enough.
So if you sat in the back, it's your own fault. You have to yell. John
Stewart, North Dakota.
There we go.
Eric Hopkins.
Larry Riggleman, Maryland DOT, Office of Materials. Bryce Worry, GSSI.
Mimi Lee, MCK Services.
JMU, Michigan Technological University. The four fellows on the back were basically traveled here with me from Upper Peninsula, Michigan.
Jeff Brunner, Minnesota Department of Transportation. I manage the road research section.
Amanda Gilliland, the Trans Tech Group.
George Chen, the Transit Group, the Veda developer and technical support.
Todd Mansell with Caterpillar.
Brian Eagle with Caterpillar.
Kurt Turgeon, MnDOT pavement section.
I'm Katie Johnson with CTC and Associates. I'm trying to take notes, so I appreciate everybody yelling when you can.
Yeah. Go ahead.
And if the people who are joining us remotely can introduce themselves, that would be effective. I'll call on you in the order that I have you. So please unmute yourselves. I see starting with Ulrich.
Ulrich Kamusugenu, work with main DOT. I'm joining remotely today. Thank you.
Great. And actually, so a good number of people here may be in the room as well. Please just go ahead and unmute yourself and introduce. And if we talk over each other a little bit, we'll sort it out. But please unmute yourself and introduce yourself if you're online.
Hi, I'm Dennis DeBork. I'm with the Federal Highway Administration Resource Center, Quality Assurance.
Great.
Rich Hamilton, Advanced Testing, New York State.
John Garrity, MnDOT pavement section.
Brian Diefender for Virginia DOT.
Joseph Podolsky, Michigan DOT, Road Research.
Tyler Carlson, Washington State DOT.
Corey Beck, Utah Department of Transportation.
I'm Shane Boone from BDI. We manage the Federal Highway NDE lab at Turner Fairbank Highway Research Center.
This is Heng Liu. I'm a contracted research engineer at Federal Highway NDE lab.
Sadek Shams, NDE lab, Federal Highway.
Maurice Arbelize, Instrotech.
Harold Von Quinas, Applied Research Associates.
Bill Feehan from the Ohio DOT. I will be filling in for Craig Londefeld today.
Judd Lundgren, Washington State DOT.
Neil Fannin, Pennsylvania DOT.
Okay, I think we may have reached the end of people joining remotely. Thank you for those of us who are doing so, especially out west in the Mountain and Pacific time zones. Sorry, we can't share the coffee with you. And we'll move on to the next item of business here. A couple quick housekeeping items. If you haven't found them already, the bathrooms are down the hall. And then haven't seen the official exit plan, but I'm guessing it's go out those doors. I came in and we'll turn it back to you, Kyle.
All right. Well,
was there anyone else?
Scipio Donisa with the Georgia Department of Transportation. I don't know if I was unmuted or not.
you were muted before.
We got you now. Thank you.
Sorry about that. You have to be on the Zoom screen in order to hit the space bar to unmute for those online.
Oh, good. We wish you were here in person, but we'll take you online. That's fine. So we're already 6 minutes ahead of schedule, and I was worried about staying on schedule. So that's a great job with the introductions, everyone. So the next topic we're going to go over is just making sure that everybody's up to speed on kind of what's going on in the background with the pooled fund and what we're trying to accomplish with the meeting today. So with that, I just wanted to go over a little bit of what we've been doing with our technical working groups. So we've been having 3 to 4 technical working group meetings yearly now. for the past couple of years. And what we've done is basically beyond kind of the large group meetings that a lot of you have been a part of with the work plan updates and the peer exchanges. We've worked as a group to identify barriers and work towards solutions for deployment of DPS as an asphalt pavement, compaction quality management, process control, and or density acceptance tool. So that's kind of a mouthful, but basically we're trying to have specialized topics that we're attacking for the DPS to try to help improve what we're doing with the technology as is, and then also advance the method. So that includes data analysis and that which also encompasses relationships with other intelligent construction technologies like thermal profiling and intelligent compaction, e-ticketing, things like that. Looking into the precision bias and accuracy of DPS and measuring dielectric and assessing asphalt density. Looking at agency use from perspective of acceptance and certification and spec development for the various state DOTs. And then of course, limitations, risks, research needs, which the acronym SWOT encompasses, which is strengths, weaknesses, opportunities, and threats. So we've been working on this kind of stuff behind the scenes, but the reason we're kind of bringing this into a bit of a hybrid between a technical working group and larger group meeting is that we're nearing the end of our work plan for the DPS pooled fund. And last fall, we had a lot of interest in trying to continue to build on the efforts we've been taking on through this pooled fund, and then also potentially adding tasks that are more implementation based and maybe in a different research direction than what we've taken so far. And that's why we wanted to bring everybody together here so we could get some input on what are some of our higher priority tasks are if we want to continue to advance the method and get use out of this technology, make sure that we're meeting everybody's needs and we're being, I guess, as smart as we can about how we advance the program. So for this meeting, what we're trying to do essentially is develop a vision of where the DPS pooled fund group should focus their efforts over the short and long term. We put together kind of a draft work plan of tasks. That draft work plan is designed to be criticized. So it's basically just saying, here's some of the things that we've identified based on feedback, but what we really want to do is refine what we have there or add or remove some of the tasks that we already have there. So I don't have too many doubts about this group speaking up and being heard, but that's another plug for please being active when evaluating this. We want to identify action items and champions that'll help us finalize the work plan. But I guess that being said, MnDOT has taken the commitment to put this work plan together. So just because you speak up and think something is useful, you're not going to be assigned any work to do it. It's our job to put it together, and we'll probably be contacting you to make sure the tasks meet your needs. And then of course, the other goal here is we got to have a mechanism to accomplish the highest priority tasks. And it's looking like the most likely way that we're going to do that is to solicit a next phase of a DPS pooled fund if we're able to get enough support from agencies and buy-in to try to accomplish these tasks. So that's kind of our big picture meeting purpose for today. The part where it could get really boring later. So we're going to have kind of our normal technical working group meeting where we have 3 different technical discussion items, and we're going to have typical, normal presentations. But then we're gonna get into kind of a recap to get everybody up to speed on items that have been identified as high priority in the past. And then get into criticizing and refining and adding and removing our current draft of the work plan, if you can call it that. So to make this part more fun and less boring, it will be great if you're thinking about what you want to get accomplished in the next few years as you're listening to these technical presentations, and as I'm kind of recapping some of the thoughts we've had in our past meetings. Jot it down on a piece of paper, take a note in your laptop, do whatever it takes to remember these kind of key thoughts that come to your head, because we do want this to be as interactive as possible when we get out of this meeting. It would be nice if we have a lot better work plan than what we brought into the meeting is kind of our large goal here. So I don't know, Brian, if there's anything else that you want to do. How do we want to handle online participation for comments and questions?
Sure, I think the easiest thing for those online would be to use the online interface, just because if you have a question, you can type it in there and we can be sure that it gets read aloud and addressed. And we do appreciate, we understand that it's imperfect being online, and some people you're not going to be able to hear. Hybrid remains imperfect is a nice way to describe the meeting experience, but we're going to try our best. We're going to document things as well as we can. And we're going to be watching that chat and listening to make sure that we get those comments. I'm going to step out on a limb and disagree with Kyle. I don't think this is going to be boring. I think it's going to be spicy as people listening to who's in the room. We have a lot of different interests in this and goals of what you want to get out of DPS. And that's great, but it also means that as we look at possible projects and tasks for this phase 2 of the pool fund, we're going to be hearing all those things, and we have a mechanism to capture all those thoughts and try to rank them and know a little bit more walking out of this meeting. So
there you go. You have the carrot and the stick today. It could be boring if you don't participate, but it promises to be fun if you do. So I think we want good participation is our unified message here. So with that, I think it's a good, the only other thing I wanted to mention is that we will be doing some polling, especially as we get towards the discussion of the work plan and trying to identify the highest priority tasks. So Brian's going to administer that through Menti poll. So I believe even if you're here in person, you're going to want to get access to your phone or computer would work also for the Menti poll, right?
That's correct.
Okay, and then of course the online participants, you'll just use whatever you're using to call in today.
And online people, if you're having any technical issues, you'll see that my colleague Katie, who introduced herself, she's listed as a co-host, and you can send a Zoom chat to her directly. She should be able to assist you if you need it.
Yes.
If they, when we're in the discussion portion, if you'd say your name before you say your piece, that would be really helpful for me and the people online.
Yeah. All right. So Hang, do you want to share your screen? I believe you're next up on the agenda.
Yep.
All right.
So as Hang's getting his screen up there, Kyle, this is Shane with BDI. Hoda asked me to just give a very brief intro on Hang's research, and since he's only got 15 minutes, I will keep it brief. But Federal Highway got involved with this just to act as an independent validation and verification of the DPS, and from a very high level, that's what Hang is going to be presenting today. So Hang, take it away.
Can you guys see my screen?
Yeah, it's not in full presentation mode yet, though.
How about now?
Oh, no, you might, well, wait, something just happened. You might be presenting, do you have two screens?
Yep.
You might be presenting the wrong screen.
Okay, let me stop sharing.
That looks better.
That's the, actually, that is also a wrong screen.
Okay. How many screens do you have, Hank?
I have multiple.
You can still see your slides. It's just, it's not in presenter mode if you go from here.
I mean, that's just
Yeah, that'll work.
make things easier. So thank you, Kai.
Yes.
So I will start with a summary of our research efforts at the ND Lab. We have done lab assessments about the DPS. We have investigated the environmental temperature, moisture effects of the DPS. We have some field implementation of the DPS as a new pavement asphalt road in the Greenbelt, Maryland. We have a monthly meeting webinar, and we participated a round robin program as a collaboration outreach. And we have several ongoing interesting projects, including sensitivity study, numerical modeling, and experiment testing. So in today's presentation, we will talk about some fundamentals about the DPS. I hope your morning coffee still works. So for the dielectric measurements methods, we typically use in the pavement testing, including the surface reflection, which is usually more used for the field testing, and the time of flight or two-way travel time, which is normally used in the lab kit. So we will talk about the scanning boundary of the surface reflection first, and then we will talk about the side effects in the lab kit. So we could potentially have better understanding of the technology. And we will close off some future work we plan to do in the coming months. To start with the scanning boundary, I would like first to give very quick review on the surveying method. One is the surface reflection method. So what we are measuring is actually the reflection coefficient, which is the ratio in terms of the amplitude of refracted wave versus the amplitude of incident wave. So in most cases, we use air launching test with nearly normal incidence. So we normally use this equation to calculate dielectric. And then for the time of flight, what we are actually measuring is the travel time of the GPR signal along the inside the material. And we know that the velocity of the EM wave will be proportional to the inverse of square root of the dielectric. And in that case, we can use the travel time to calculate dielectric. This is the normal formula we see in the many reports, papers, and the publications. And the motivation of our work is more likely in the past studies, many people have investigated the surface reflection and the two-way travel time. They have obtained different results for the same test. And more specifically, some people saying the surface reflection will be more like surveying the thin layer underneath the surface, while the two-way travel time is more like an average dielectric measurement of the specimen. So in this work, we would like to answer the question, especially how thin is the thing. So we want to identify the scanning boundary of the surface reflection method. So we could potentially understand why we get different results between the two methods. And the asphalt material is kind of interesting material. It's heterogeneous. You have multi-phase ingredients. You have aggregates, you have binders, you have sands, you have alloys. So it's very interesting that how the material interact with the GPR signal. So to start with the scanning boundary, I want to talk about the Rayleigh scattering, which is happening when the wavelength of your EM wave is approximately equal to the size in front of the travel direction. So normally the EM wave will travel in a straight line. And if you encounter a obstacle that is about the same size of your wavelength, your travel direction will be changed in any direction. So for example, if you have a 2 gigahertz antenna for the GPR, in the air, their wavelength is about 0.15 meter. But underneath the asphalt, because we have a very high dielectric, the wavelength will be decreased to a number that is around 0.06 meter. But in the asphalt, you could have an aggregate, let's say you have a 19 millimeter diameter aggregate in your asphalt. The size of the aggregate will be similar to the GPR signal, so you will have scattering effects in your asphalt. So because of that, what we actually measured with surface reflection is the superposition with the surface reflection plus the scattered signal underneath the surface. And because of the Rayleigh scattering, we know that this scattering will be proportional to the reflected signal. And I don't want to get too much details, but the core idea is that what we measured from the surface reflection is the superposition of the actual signal plus some noise signal that from the aggregates underneath the surface. And because of the superposition, you might change the amplitude of your actual value, and it depends on the contribution from your scattered signal. It might be positive, it could also could be negative. And the change of your amplitude of your reflection will change your reflection coefficient. And from this formula, we can plot saying that your reflection coefficient is more like a monotonic relationship with the dielectric, which means whatever you change in your reflecting signal, you will have the same direction change in your dielectric measurement. So this, I want to skip, this is our theoretical model, how we calculate the scanning region, but we just go dive into the actual results. So we studied, let's say you have an antenna with a separation distance about 4.4 centimeter, and you place the antenna about 1.2 meter above your surface, and you change the center frequency from 2 gigahertz to 0.4 gigahertz. And you can observe that your scanning region will be expanded larger and larger. So for the 2 gigahertz, your penetration depth is roughly around 2 inches. And if you want to want your signal penetrate depth deeper, you have to decrease your center frequency of antenna. And we then study how the antenna height might change the results. And if you, for the same antenna, and this is a typical result for 0.4 gigahertz, and you have similar results for other frequencies as well. So if you increase your antenna height, you will see that your penetration depth will not change. But the only change is the coverage on your side of your scanning region. So that's the basically a finding of your scanning region of your surface reflection method. So we have done some numerical modeling to verify this finding using GPR Max. So we model the asphalt as a heterogeneous material with 3-phase integrants. So we model the binder, aggregates, and the elbows inside the material. And if you compare this model versus a equivalent homogeneous model, you will see that the main pulse will be the same, but you will observe the scattering from your aggregates underneath the surface. And you can see this effects, and which means this model can be used to investigate this effects. And this is an example of a numerical modeling. So we have a aggregate gradation with different size, with different percentage and along the material. And because of the limitation of the GPR Max, for those very small aggregates, we can assume them as a continuous material and combine them together. So we only model this 4 major aggregate. And in this example, we will assume a 5% air voice and 5% binder. So we first built a model. You place the antenna about 0.2 meter above the surface. And the red line will signify the scanning region that we derived from our theoretical analysis. And you use the surface reflection method. You can calculate that dielectric about 5.48. And then we do a model that we keep whatever inside the region the same and replace outside area as all fine aggregates with an increased dielectric about 6. So if the surface reflection can sense this change, you should get a different dielectric measurement. But unfortunately, your surface reflection will give you the same dielectric as we expect from the scanning region study. And the third model is that we add a big hollow denomination, which is a L voice, to represent that you have a larger voice underneath the surface. And if the method can sense this change, you should give a different dielectric, but unfortunately, you still get the same number by using the surface reflection. And this is the time series of the 3 model. As we can see that the main pulse that you're gonna use for surface reflection calculation, which is here, you got exactly the same number here. So that's why you won't get different dielectric measurements for the 3 model. But we can also observe the scattering or the reflection from the hollow voice. The wave, you will see big difference after that. But again, this won't change your calculation using the surface reflection. So which kind of verify our finding about the scanning boundary of the DPS using the surface reflection. So then I will move to the side effects in DPS. So the side effects is more about the lab kit. And we use lab kit to test the cores or pucks. And because many practical reasons, the size of the puck will be limited within 6-inch diameters. And a paper or a private study by Kai has revealed that you potentially have multiple sources of noises in addition to the surface or to the bottom reflection, which means it will change your calculation of your two-way travel time. Oh, I want to mention that in the lab kit, we mostly use the two-way travel time, and it's kind of different from the surface reflection. And because of the, and from this figure, we can see that with in some region, the gray line represents the bottom reflection here. You have very close interference from the edge reflections or edge critical reflections. So in that case, your calculation of your travel time will be influenced by those noises. And we are trying to study how much influence that would that be for this kind of a setup. So we call the side effects as the change in dielectric due to the limited size of your puck. So we measure the study. We measure the GPR signal using the RDM2. So we'd like to thank Dr. Roberts from GSSI for providing access to the raw A-scan measurement, so we can take the measurement and calculate dielectric with our own method. So this is we developed a spreadsheet to basically calculate the dielectric based on the raw measurements, and we also compare our measurement with the software, and we get very close results. So in our calculation, we assume the straight ray path for the GPR signal. So it might be a little bit different from the assumptions that has been made in the RDM software. So we first did an experimental testing to confirm the existence of side effects. So we first built a large enough slab. So your side effects or the reflection from the edge will arrive much later than your target signal, which is the surface and bottom reflection. So we take the measurements using the machine DPS, and then we take a core from the center. And so we can maintain, keep the most parameter to be the same, including the materials, air voice stuff. So we take another measurement if the difference between the two will be most likely the edge influences on the dielectric measurement. And in the first trial, our slab thickness is about 80 millimeter, and we observe a significant difference about 0.11 in dielectric change. So the Ashton spec limit is about 0.08. So this number already exceeds that number. And we have done some numerical study suggests that if you increase your height of your sample, this size effect will be lower. And we did another step testing and increased the height of the slab about 106 millimeter. And we do observe a reduced size effect about 0.067, which will be within the limit of your Ashton spec. So this is how we do the numerical modeling. We model a pair of model. One is that we model the actual size of your specimen. One, we basically assume the diameter of the puck will be infinitely large, so you won't get a reflection from the side surface. So in that way, we can compare the two models and identify the size effects. And we model the a numerical model based on the scanning procedure of the DPS, follow the exact same procedure steps. So we can use the same method to calculate dielectric, which has been used in the lab kit. So this is a kind of breakdown of the collected signal following the steps. You can first isolate the surface reflection, and you can also isolate the bottom reflection. And in that case, you can calculate the two-way travel time, and again, you can calculate the dielectric. So the advantage of the numerical model is that you can control everything, and you can do subtractions and isolate the size effects. And in this case, the black solid line would be the model with size effects, which means I model that with actual size. And the solid red line would be the model without size effects. So it's an infinite long wide model, and difference between them will be the size effects. And in some cases, the size effect will arrive later than your reference peak, which will be used to calculate the travel time. If that's the case, the size effects will not change your calculation. But in some cases, if your edge effects arrive near your reference peak, so your reference peak will be changed in terms of value and timing. But two-way travel time only cares about the timing. So the timing changed, the dielectric change, and that is the basic principle behind your dielectric measurement of this edge effect. And this is a little bit summary about the study. And because the diameter of the puck cannot be changed, we studied trying to study how the height would be changing the size effect. We studied from 30 millimeter to 170 millimeter, and we studied 3 different materials with 4.5, 5.5, 6.5 dielectric. And we observed that around 80 millimeter, you will have a severe size effect that will be larger than the spec, and kind of agree with our experiment testing. And the model will suggest you if you have a height larger than 100 millimeter, your size effect will be minimal. And our experiment testing also kind of agree on that part. We are planning to do more slab tests to give us more extra experimental data points to verify our finding, and that is our part of our future work plan. So our future work continues with the sensitivity study, size effects, and we'd like to mention that we have a new payment testing facility will be constructed at Turner Fairbank. So our original sensitivity study trying to understand how the mixed design would change the dielectric measurement. And this is our original text matrix. We are trying to study how the aggregate types, aggregate size, gradation, and binder content will change the dielectric measurement. After consulting with UNH, and we'd like to thank UNH to provide for providing us the goal measurement data from the IDEA project. I think we have a overlap on the study parameters, and we kind of change our plan, and we plan to take advantage of UNH's data and combine with our numerical modeling, and to see if we can crank out some new findings from the study. And for the slabs, we are planning to construct some thicker slabs. Now we have already have one in place, and we are waiting for the cooling, and we will test them soon. And we have a new constructed pavement testing facility in Turner Fairbank. So after construction of the pavement, we will implement the DPS, and we will compare the TBS results versus the nuclear density measurements, and hopefully we can promote the TPS to a wider audience with more promising results. And thank you. We welcome collaborations. If you have any ideas, please contact Dr. Hoda Atari for potential collaborations. Thank you.
Right, thank you very much, Hang. Yeah, just a comment on that. While I think, Joe, are you up next for on the agenda? So while Joe's pulling up her slides, I just wanted to mention that some of Hang's work with the simulation and then the experimental work they're doing has been great to both validate some of the things we can see experimentally, but then also generalize it to really quantify, for example, the side effects on our pup testing, the heights that we can expect to have good unbiased results. So I really appreciate you sharing that with the group, Hang, and I think it'll come up, some of the work you're doing as we talk about our work plan moving forward.
So just quickly, I mean, one of the takeaways, it looked like 100 millimeters is really then kind of the minimum where we want to be from a puck. You'd like to be, yes, which is kind of what we observed just empirically, but it's good to see the validation.
Yeah, and then also the other thing, the size of the aggregate and the effect on Raleigh scattering, kind of confirming the more uncertainty we see when we go out there on projects with larger max aggregates.
The depth of penetration.
Yep. Also, so it's three different examples like that where, doing the experiment, you can only do so many depths, but then when you have a validated model, you can kind of really refine that stuff.
Actually, it's a quick question for Fan, for him that is the numerical modeling using finite element or discrete element?
It's a GPR max. It's a finite difference time domain method.
Okay. Thank you.
So for Joe's presentation, we're gonna try to mute the conference room microphone and let her unmute herself right on her machine. So give that a shot.
All right. All right, try that. All right. All right, so thanks for the opportunity. What we're gonna do, I'm gonna cover is just an update on what UNH has been doing, following up on what we had talked about a little bit during the meeting. What was it? It was the end of November, early December. Let's see if I get this to advance. All right, so just an outline, we'll go through some of the work that we've been doing on task 2, which is really looking at how do we evaluate sensor bias for the field dielectric measurements, a little bit about the next steps within the pool fund study. And if I've got a few minutes at the end, we had been working through developing the AASHTO or refining the specification, AASHTO specification for the lab dielectric measurement, working with Kyle. And so I can kind of give an update on that as well.
Sorry.
Sorry.
Yeah, I guess they're replacing batteries or something, I don't know.
All the So the task 2 of the work that UNH is conducting is looking at sensor bias using the swerve measurements and the fiberglass block data. And then looking at how do we develop those acceptance criteria and the checks for the sensor bias and recommend any changes to the current protocols for conducting the field measurements based on that analysis. And all of this data processing is incorporated into the analysis tool that we're developing that's officially under task 5, but it's kind of being built as we do the other tasks. So we've got the initial tool that pulls in the data, helps to identify data that doesn't make sense so you can clean it up. And then we've also got the additional capacity to do the sensor bias checks on the swerve measurements built into the tool now as well. So the data that we use for developing the sensor bias check, we've got a group of 7 different basically test section data that we got from Kyle. You can see the number of testing days that it covered, as well as kind of the range and the length of the swerve measurements and the specific sensors that we used. So the data that we're doing in terms of, or the approach that we're taking, so we're first taking that data and breaking it down into the individual sensors. So you've got the 3 sensors, and if you're standing behind the DPS, they're numbered left to right, 1, 2, and 3. So we look at the individual sensors and then also combinations of sensors. So we look at the combination of sensor 1 and sensor 2, sensor 1 and 3, 2 and 3, and then all 3. And then look at comparing means, medians, and standard deviations for all of those different combinations to each other over the course of 1 test day, breaking the test lengths down into different sections, as well as the overall project. Okay, so looking at different combinations of those. So there's a lot of data analysis that was done, a lot of different combinations. And that's all being documented in the task 2 report that we're just finalizing now. So you'll all have this available in a written report format. For the statistical analysis, again, we're using the current protocol, which is looking at the median values, okay, and comparing those to the existing thresholds of maximum difference in medians of 0.1 between any 2 sensors or 0.2 between all 3 sensors. And then we also looked at the average values for each sensor and compared those to the standard deviation of those respective combinations for comparisons. So again, the results we're looking at in terms of projects, in terms of sets of sensors, and test section length breaking down. And then broke it down into just the general statistics in terms of how many times or what percentage of the data do we see that exceeds that threshold criteria. So just to graphically go through what each of these really look like, the criterion 1, which is the current protocol, takes your measurements from each sensor, calculates the median, and then you're looking at the difference in the median values in terms of the actual dielectric value. And if it exceeds 0.1, or if all 3 exceed 0.2. Okay, so this is a relatively straightforward approach. The issues are a little bit higher or a little bit lower. Those threshold values are different relative percentages. So it's not the same criteria for every single dielectric measurement, which is why we started looking at the alternative criterion, okay, which is looking at calculating the average value and then comparing those differences in average values to the standard deviation, okay, of those relative or respective combinations. Okay, so in effect, you're normalizing it based on the actual dielectric value instead of a straight up threshold. So just to give you a snapshot of what the overall data looks like. So this is all of the data combined. If you're using the standard deviation as the criterion, okay, about 17% of the data showed that there was potential for bias. If you're looking at the dielectric thresholds, depending on which criterion you're looking at, whether it's 0.1 for 1 sensor combination or multiple sensor combinations, or the 0.2, okay, depending on which one of those you're looking at, somewhere or up to 34% showed that there is potential for sensor bias. Okay, so considering the amount of data that we've got, there really wasn't a lot of bias okay, that was detected using either approach. So just to summarize the results, okay, so really for the data that we have, again, which was relatively limited, similar dielectric measurements for all of the Minnesota sections, either the average or the median really is reasonable in terms of what you can use to represent that variation of the individual sensors. When we looked at the sets of sensors, so example, just, one set of sensors on different projects or different days. In some projects, they were within the criteria. Other projects, we identified bias with one or more of those specific sensors. So that could be pavement variability, or it could be sensor variability. But again, relatively infrequent in terms of what we saw for bias given the size of the data set. In terms of the test section length, when we broke those down, so if you look at, for example, a test section that was 600 feet, when we broke it up into, say, 250 feet sections or 100-foot sections, essentially we're getting the same identification of which sensors are indicating they might be biased regardless of those test section length. So in terms of recommended changes for the protocol based on the analysis that we've got conducted to date, current protocol is 250 feet for a swerve measurement. Based on the data that we've got, really shorter lengths could be used. 200 foot, with the amount of data that we have, really looks like it could be acceptable. 100 feet, you could push it down potentially to that, although sometimes you don't always capture everything that you do with the longer sections. So if you really wanted to push it down to a shorter length, we really want to do some more data analysis to make sure that really is capturing the potential. In terms of the tool, what we're recommending is, since we've got the capacity built into the tool, go ahead and do both approaches for looking at the threshold. So calculating the mean, median, and the standard deviation for those dielectric sensor, for the values for each individual sensor and the combinations of sensor. And again, that allows for flexibility in terms of if you've got different dielectric values, you can look at both approaches, and the tool does all of that now. So for the current protocol, again, continue using the median values. Okay, the highest and lowest median values, making sure they're within 0.1 of that middle value, and then the maximum overall difference for all three sensors being less than 0.2. And then the additional protocol using the averages and standard deviations and making sure the differences in those averages are within the standard deviation of that corresponding sensor pair. So with that, looking at what the next steps are for the UNH work, for the task 2, again, we've just gotten the fiberglass block data, so we're going to be doing the analysis there and looking at comparing where the fiberglass block validation or sensor bias check, agrees or disagrees with what we're seeing from the swerve measurements with this protocol that we've developed. So that's underway right now. We've got that data. Under task 3, we're starting to look at more of the correlations between the lab and field dielectric. So that's, again, some of what Heng was talking about, the surface reflection versus the lab measurements, which mostly are the time of flight, but we also have some surface reflection information on the lab data as well. Looking at multiple levels of analysis, so individual specimens, lots, entire projects, and looking at how do we, what is the aerial domain in the field that corresponds to a specific core location. So doing that on a statistical basis. And for the protocol, trying to look at this point, if we're still using cores for the field validation, how many do we really need to be taking? And then for task 4, under that, what we're starting to work on is identification of, where those varying areas of density are longitudinally and transversely, and what do we really need to do in the field to represent full coverage of that match. So that's ongoing. And so I think what I'll do, I'm trying to get everybody back on time here. So any questions on that before I do go into just the update on the ASHTO spec?
John Stewart from North Dakota. I guess, are we gonna be looking at, we have multiple carts, how many sensors are we planning on, and then if we have carts from different vendors, sensor buys between those, is that part of the plan, or?
So the question for the online group was, are we gonna be looking at multiple carts for sensor bias and multiple vendors for sensor bias? So the people online.
So right now, that's not part of what we're doing in the work plan. We're just looking at, one set of sensors. I mean, up for, if we've got the data, we can do the analysis. The question is gathering the data and adding that into the task that we're doing. And again, a lot of this, this has been kind of a moving target in terms of the tasks. We've already gone through one iteration of, as things have progressed. And I think that's appropriate to do.
I think that's something we need to consider moving forward.
Yeah.
Introduce more vendors in the market, and also if we have for QA, they're on the same project.
Yep.
Joe, the method of debug can be applied to any vendor.
To any vendor, right?
Any vendor. So we just debug stack, hopefully put in action. Okay. Any vendors come to the market, they want to be have to be stack.
Yeah. So the tool can take whatever data. Yeah.
North Dakota Department of Transportation Gold Star for the day, because those are exactly the comments we need to address. Because either, in my mind, we have one of two options. We can either specify that you have to use a single vendor equipment on a specific project, not that you specify which vendor you use, but or if we're gonna allow them to mix and match vendors, the protocol needs to address that. So I think that's a very good comment and something we need to address either through how we specify the data collection or how we do the analysis. Without going into too much details, it seems like as of now, just because of the different center frequencies that you get from different vendors, it seems like initially allowing multiple different vendors on the same project is probably not an option that we're gonna want to do.
Yeah. I think that's going to give you, I don't think different vendors is going to affect how you're doing the sensor bias checks. That's just, the bias between individual sensors on that particular piece of equipment. If, one sensor is off, but where it's going to come into play is when you're talking about that relationship between the field's dielectric and actual density. That's going to be a different calibration potentially between different vendors. And that's, I think, where it comes in to play, not so much on identifying if you've got a sensor that's off compared to the other ones.
This one chime in. This probably for future certification. George Chan for trend. So I've been with profiling group for forever. We give a certification for inertial profiler, no matter what vendor they do. They go to the sensor check with the bounce test, sensor tech bounce test, and then test track have reference data versus vendor's data. So that will solve one standard for all.
And then that into the CFR compliance aspect for federal highway needs to use it for quality assurance, for acceptance.
You want me to do the quick? Yeah, yep.
Great, but thank you.
Okay, so just quick update on where the Astro spec on the LDMS side stands. So we talked a little bit about, what we'd been doing on the NCHRP idea project. And so that was to develop the standard practice for the dielectric measurement in the lab. In terms of the requirements and the calibration procedures. So it covers the equipment. And again, it's generalized for different vendors. It's not a specific vendor. The compacted specimen size. So right now it is limited to no shorter than the 100 millimeters, which agrees with the work that's been done with Federal Highway. And then the test procedure, which we had discussed last time, which is the 3 measurements 120 degrees apart. So there's no flipping of the specimen. It's just 3 independent measurements. So the operation requirements, so we've got the specimen dielectric variation, the dielectric block range. So right now it's the high density polyethylene. And so you've got the range, and then we've got flexibility built in right now that if there's a second reference material that we decide that folks want to use, just want to make sure that there's a minimum value for the error for a second reference material. Again, this is the protocol for the measurements. So the 3 separate orientations, 100 degrees apart. You look at the max and the minimum value. If they're less than 0.02, then you can just use the straight up average of those 3 measurements. If it's not less than 0.02, determine the largest. Okay, you can repeat a single measurement, or depending on how far apart they are, redo all 3 measurements. And then with those 6 measurements, do a trimmed mean. So drop the high, drop the low, and take the average of the middle 4. So based on all the research that we've done, the statistical work under the IDEA project, that gives you statistically the representative value for the dielectric measurement. So that's all put into the draft Astro spec. And I don't know where that stands. I guess it's a question for Kurt, right? Excellent.
So what's happening is
Okay, it's now on. Oh, on video, it is not. Yes, I'm speaking. Share my slides. So I will also try to keep us on schedule.
Yeah, and Derek, but do your full.
I will, absolutely. Yeah, we've got it set up. And I'll kind of take a similar approach where I've got bullets, and you're welcome to read those, but I'll just kind of talk through things generally so I don't take us too far over in going through things methodically. So I'm here to talk about the mobile asphalt technology. Okay, all right, in here? Sure, okay, yeah, thank you. So my name is Derek Tompkins. I am a senior engineer with Applied Pavement Technology, and we supported the Federal Highway Administration Mobile Asphalt Technology Center on their DPS loan program, where they issue DPS devices to agencies or contractors who are, free to use them as they see fit. But we also developed some training and demonstration materials for those folks. So I'm going to just talk a little bit about the participants in that program, the resources that we developed and presented, and just some brief outcomes from that loan program. So first, I'm going to just page through some front matter for Federal Highway presentations. So this is a disclaimer you can read. And here are some acronyms that we'll be referring to possibly throughout the presentation. And so again, as I mentioned, this is an opportunity for people who are interested in DPS technology to apply it to their state roads or their paving projects and learn more about it. So it's a guided tour through the device. And so throughout that, we developed different reports. We developed, guides for participants in the program. And then we also visited them in their facilities and went out on a paving project with them and assisted them in the use of DPS. And so this is an idea of the team. So myself and Prashant Ram at Applied Pavement Technology, and also with Federal Highways. That's Leslie Myers with MATC. Steve Cooper's in the room here today, and Monica Horado with the FHWA Resource Center. I don't know if Monica's on the call, but we have a few slides from Monica here that I'll be going over later in the presentation. So I've got kind of a clusters of slides to present to you. First, I just want to tell you about our loan recipients, the participants in this program, and the materials that we developed and presented to them, just kind of the general experience that they had in training and demonstrating the device. So some of the DOTs who had loaned the device are participating in this call. And so you're welcome to browse this map. And again, this program, AppTech, was involved in the 2021 and the 2022 demos. However, this year and moving forward, MATC is taking that over. So they're now using and expanding on the materials that we developed. And so they're going to continue to be demonstrating and training other DOTs and contractors in the use of this equipment. So what the training and the demonstration involved was like kind of a pre-call where the MATC sent them the device. And so we would get online. We're using the virtual technologies as well to contact them, maybe, set up the gear and do a really quick calibration and maybe a validation run, just to make sure that before we come out for our training event, the equipment is working. If, there's some issue, we could contact the vendor and help them, have them help us work through whatever issue we may have. Fortunately, we didn't run into a lot of issues. And then we had a involved 2-day training event where we were on site. Due to COVID, we had a few of the events were virtual, but most of them were in person. So on day one of the event, we were at the either the agency or the contractor's facilities, and we took a real hands-off approach in everything we did on DPS. So we encouraged everyone who was, in the room to get up and push buttons, set up the device completely, connect cables, and do it all. So you can see some photos there in our slides, just folks using the device or setting it up or tearing it down with our assistance. And then we had a very extensive slide deck that we would present to inform them of the technology. What is DPS? How does it work? Procedures, field use, concerns about calibrations and validations, things like that. So we just, again, it's instructive and it's not intended to be one directional. So we had a lot of collaboration on those with our participants. And then on day two, we would go out into the field with them on an ongoing paving project or a recently completed paving project. And we would allow them to do everything on their own, them being either the agency or the contractor. And we're there looking over their shoulder. And I think that this was the real the big success of this training program and the real value in this program is because, as you're all aware, when you're any new piece of technology, a lot of times there are little hiccups that can wind up consuming a lot of time. So if you just taken a new DPS device and let's say you briefly lose GPS connectivity, when you first have a device, that could potentially be a half of a day of a shutdown, just trying to figure out what goes where, why did I lose it, how do I reconnect it? But because we're out there on site, we're able to reassure them that, we can get this connected, and really all those hiccups were reduced to a matter of, maybe a 5-minute distraction instead of being an hour long or half day thing figuring out what do I do now. So, and again, some of the recurring issues that we had were, GPS connectivity, just, general of it. Sometimes the DMI would go out of whack, and instead of it being a major crisis, we just say, okay, let's, walk off 100 feet with our wheel here, mark it off with chalk or paint, and let's recalibrate the DMI real quick and make sure everything looks okay. And, it's kind of reassuring to have someone there just kind of looking over your shoulder with an answer for pretty much any problem that we ran into out in the field. And so now, and also afterwards and during the training, we were also involved in on-call support. So we would get calls from DOTs saying, I did this, it's not working out right. We ran a validation. We did the swerve tests and everything's out of alignment, or, we're not within our tolerance. What do we do now? And a lot of times it was as simple as saying, well, shut down the equipment, restart it, reconnect your cables. And eventually we would sort it out, so we were there to help them use the device, because again, after our training, then it was up to the device, to the state or the contractor to use the device however they saw fit on as many projects as they wanted. And so we wanted to support them through that continued use. And so there were a total of over 30 paving projects that were explored using the DPS device by the agencies and contractors. And so then following up on that, moving into the future, the Resource Center has also developed what they're calling a DPS 101, which is kind of a virtual training session ahead of the visits they'll be doing in 2023. And you can contact Monica Gerardo with the Resource Center for more information on that. And I'll talk more about this at the end of the slides. So the next thing to talk to you about briefly is the outcomes from this. So first up is the number of different mixes that were effectively tested with lone DPS devices. And it's and so, there were a lot of conventional mixes that were tested, high fraction wrap mixes. We really only had one mix that caused us some issues. This was MassDOT's experience using a mix that had a magnetic aggregate, and we don't know exactly what that is. We've reached out to them, but this is something that hopefully all the agencies, and you are all aware of this, to keep that in mind, that aware of what your aggregate is. We also had the lone participants attempting to use field cores to do their mix calibration work and just kind of learning on the device. Part of the training, we're making them aware of the requirements for specimen dimensions, but a lot of times they're wanting to explore with this, and some agencies had a large stockpile of field cores for mixes going back decades and decades, and they were hoping to develop like a dielectric library using those stockpiled cores. So we tried to support that as best we could. So two of the participants were Michigan State University and the University of Connecticut. Were both actively trying to develop kind of a large library of dielectric information on their state paving mixes. And so that's why we have these plus signs by the mixes, because there's still some data trickling in from some of the lone participants who had worked in this. But we had really active participants in this regard. And they, again, part of their participation in the loan program is that they're going to share their data with the Federal Highway Administration so that they can database it. So we had a lot of lab data and a lot of field data that we received from those participants. And another thing we wanted to another outcome is reporting on their experiences with the device. And I won't read through these, directly, but one major outcome was that when we first started this, there was the thought of, well, maybe stationing is good enough. Maybe some agencies aren't that interested in GPS. So we weren't actively, talking about different GPS or manufacturers and how to assure connectivity for those devices with the DPS device we used. but it became evident pretty early on that pretty much everyone expected to be able to use, sub 1 meter GPS in tandem with the DPS cart, which I'm sure you're all aware of, or in practice of doing, but we wanted to support both just in case someone was more interested in trying to use stationing, but that complicates field testing, particularly in the demonstration. And another outcome was just the shared experience that operating the DPS device itself, in the cart mounted operation on the pavement is a one person thing for obvious reasons, but there's a lot of secondary activities that a second person can do. So in the cart mounted unit, I think everyone agreed that it was good to have 2 people on site for a given test day to make sure, have a safety lookout, have someone who can help you with the validation and setup and tear down. Just, basic things like that, keeping notes if you need them on field data collection. And the last thing is that the general experience from a lot of participants was that they felt that the data analysis wasn't as straightforward as they would have liked it to have been. And this is maybe suffering from comparison with how they consider asphalt density now, which is a newt gauge, and you set it down, you click it, you move on. So this may not be fair to DPS technology, but a lot of them reported that they didn't feel they had enough time to do the analysis that they wanted to do with the data, and they wanted it to be a little bit more straightforward. And one thing that we should note, the vendor for the DPS was GSSI, and they were very responsive throughout the loan program and assisting us, whether it was in resolving connectivity issues, resolving sensor difficulties. So we really appreciate their support throughout the loan program. And then finally, we asked the agencies and contractors just to give us their perspectives on implementation. From most of our participants were agencies, and they all noted, and in all of the training sessions, we had a lot of contractors who were present during the training and who used the device, were very interested in the device. So it seems like there's interest. Everyone's fully engaged and wanting to know what comes next. But the 2 big question marks in terms of implementation were, specifications, what's this going to do? How am I going to need to use this? And another bigger one was just associated costs with DPS use. Like, how does this affect my staffing, based on how I do QA/QC right now? And this is from both agencies and contractors who are concerned about that. How am I going to afford to get more people? I can barely hire people right now. Who am I going to get to go out on this cart? Do I have to have a special person? Can I just throw an intern on it? How much training do I have to give an intern to get them to use this reliably? So on and so forth. Also, traffic control and project delay considerations were raised by almost everyone. How does this affect our paving operations? Is this going to slow us down? Are we going to have trucks sitting out with mix getting cool? So, and we hope that and we resolved all these questions or discussed them with them, but these are things that are hanging out in the air for this group to potentially address and assure others with. And so the last thing I'd like to mention, we also received a lot of data from our participants, and the Federal Highway Resource Center kind of performed some first stab analysis on that data, and then they communicated that to the participants, whether it's an agency or a contractor, get first use. And again, as I said, that database that's being built by the Federal Highways Administration is online at the Info Technology and Info Materials websites. If you're interested in looking at, accessing, or using that data, I believe that it's able for you to be downloaded or viewed at least. And again, moving into 2023, there will be continued loans of the equipment. And one's already occurred in the city of San Jose. There's, I believe, someone here from MCK. Yes, so they had a demonstration. I think MnDOT may have taken part in that as well. Is that correct? Yeah, there you go. So, yeah, that's great. And so there's going to be more plans. And I believe that these are all set up and ready to go. Michigan was a participant in the first round, and they've wanted it again. So they're one of the agencies with a stronger interest in DPS. So they wanted more of it. And then also as a part of the mobile asphalt trailer site visits, they will have the DPS technology with them. And I think they'll be doing some training and demos for those folks that they'll be visiting. And finally, coming soon, and this is a slide we kind of added in the last minute, we're tentatively planning for late August 2023 to kind of have a roundtable or a peer exchange on the loan participants today. So this is something that will there'll be more to follow on. So just to keep an eye out for this. And I see that MnDOT will also be participating. I don't know if you're aware of it, but you'll be asking for an update on the pooled fund as well during this. So hopefully you can participate in that. And I believe that is the end of it. Thank you for your time. There's the folks. So this is the last demo in San Jose. So thank you. If there are any questions, I'll be happy to answer them. Otherwise, appreciate your time.
Hey,
For our
Derek.
remote participants.
Hi, Leslie. Are you able to hear me?
Yes.
Hi. Yeah, I just wanted to thank AppTech for their support and getting the equipment loan program off the ground for the Mobile Asphalt Technology Center. And just reiterate that, yeah, what we are thinking of doing is trying to set up in tentatively August or September, couple hour online, just like a dialogue between past loan and current loan recipients. And yes, MnDOT, we are going to ask you to participate in that. And the reason this came about is a few of the loan recipients had said they had interest in finding out what was the loan experience like for others. So, Missouri DOT, for example, Dan Ash said, gosh, we used it on these 3 different projects, but we're curious, what were the results on other projects? Massachusetts DOT used it on some crumb rubber projects, and they were curious, who else did and what were the findings. So one thing that Federal Highway has identified as a need is, maybe just having this open dialogue, have a couple of presentations to get things going, but then just let people talk. And I just came off of a call before this one with the Eastern Band of Cherokee Indians in North Carolina, and the Cherokee DOT is interested in borrowing the DPS. They maintain a pretty big network of roadways in Smoky Mountains, and they do their own inspections and things like that. So I think one of the curious things that I'd like to hear from the group as things progress is, are there, how does network size play into the implementation of this? And I see Jonathan is here from North Dakota DOT in the room, and they've got a lot of experience with implementation of that. But I think looking ahead, one of the items that maybe the group could come up with is like applicability of this. Does your network size make a difference? Should it be like a tiered implementation if you have a larger network size, whether it's geographically large or just, mileage large? But I think that's the types of questions that we're starting to get as the interest is growing from some of these maybe, smaller agencies that are not just the state DOTs. So thanks. That was a great presentation, Derek. Good job.
Thanks, Leslie. With regard to the fall meeting, I don't know what your thoughts are on combining. We typically have an event, as you know, closer to the winter. We try to wait until the Minnesota construction season is winding down. So at least sometime towards the end of October, and we've gone as late as the end of November. So that might be an option to combine those events if you're interested. Just a thought.
That would be fine. Yeah, we can talk more on that. I think the big thing I'm hoping is that we can keep presentations to a relative minimum and really facilitate breakout sessions, even though it's virtual, but maybe that is something, if you think it's something that could be combined with your meeting, that would work well.
Well, you can run that portion of the meeting then. You just signed up. So
can Joe help me? We have experience with this kind of thing.
There you go. All right, well, thank you very much. And thanks, Derek, for your presentation. So with our, yeah, so I'll present my screen because I'm up next. I can get it in here.
Derek, just real quick, cost on the system? Was that something, so they were aware of the cost, or did they just assume that it was a very expensive system?
they were aware of it.
Okay.
Did the one user who used Beta have a better experience?
Where does he answer that?
All right, I'm stepping in.
One thing that they mentioned is that they had, at the time, they were only allowed to use one mode of regression analysis for the voltage dial.
This meeting is being recorded.
And density decision. So apparently that was in process, like that change, but that was the company.
Well, Granite used it.
Yeah.
Granite Construction.
Yeah, that's who Kurt's talking.
Okay.
Okay, so with our latest agenda, this next item is presenting potential topics for new pooled fund work plans. So the goal here is I still hope to be done by 10:20 to give everybody your break. On the current schedule, we have a break from 10:20 a.m. to 10:40 a.m., which I want people to be recharged because that's before we get into the potential work plan discussion. So we'll go through some of the items we used in developing our work plan with the goal of getting everybody up to speed on what we're taking a look at and where these topics came from. So some of the items that or the materials we used to develop these tasks that we're going to evaluate were a Menti poll from our TPF meeting last fall. So we had a lot of good discussion, and CTC kind of summarized some of the main topics from those Menti polls. So we'll go over that just a little bit to refresh everybody's memory and actually update the people who haven't been part of the technical working group meetings. Herb Ducats hosted a really nice workshop that also included some polling questions with a larger audience that's included some people who aren't part of the DPS pooled fund. We wanted to incorporate those thoughts into it. We had a good discussion as part of our previous technical working group meeting, so I wanted to briefly go over the thoughts that were shared there. And then we've been meeting periodically with Federal Highway and gotten some good ideas on ways that we can focus our effort to make an impact with DPS. And then, of course, from presenting at various conferences and the feedback that Leslie's group has gotten with the equipment loan program. And then also things such as what Peng presented with the simulation aspect are kind of shaping the topics that we're going to look at later. So we have about 20 minutes, so let's take a look at some of these results from previous. So, and some of these are going to be a little bit redundant, which is a good thing in the sense that that means we're hearing it from multiple different groups, and those are the things that we definitely want to take a look at and address when we develop this work plan. So the question we asked last fall was, what do you see as a main barrier to DPS implementation? So of course, the cost of the equipment it's a significant investment, and we'll be able to discuss this later. The good news about DPS is it's addressing an issue that obviously has huge financial implications in terms of how long our road networks are lasting, and that's something we're gonna look at actually as a proposed task, how we can justify the cost of the equipment if in fact we think it's justifiable. Training was a big one in terms of both collecting and analyzing quality data. We want to make sure we're set up that the available kind of pool of DPS users is able to address the amount of data collection and analysis that we need. to continue to build the program. We're doing AASHTO, both field and gyratory sample AASHTO specifications. And we do have MnDOT field collection on the website, but we need to continue to develop and be strategic with our standards so that new users and people who are just getting their hands on the technology have something they can understand and get quality data by following these standard practices. Equipment accuracy is something that we're continually looking into, but still needs to be better defined. I think, you know, just looking at these things, continuing to have kind of a live list of appropriate and challenging circumstances to where DPS can or shouldn't be used would be helpful as we build out our user group. Always trying to make sure the equipment is in a spot where the way we're using it, it's not going to break down in the middle of the paving project. And if it does, how do we address that? Construction is kind of a different animal than a lot of the non-destructive testing technology, in that if we're implementing this as part of quality assurance, eventually it needs to be treated as paving equipment. And I think this kind of thing is helpful to have, you know, industry partners like Caterpillar and others on board giving feedback on how we can make sure our deployment of the technology is something that can be expanded for routine investigation. A lot of talk about setting up equipment and certifying equipment, and this kind of goes back to what John was talking about, and then George commented on, is how do we make sure as new vendors come to the scene and as technology changes year to year, that we have a means of making sure we're going to get quality DPS data from that point of view. We've been presenting case studies at MnDOT for a while now, and through the loan program and also other DPS states, we have some kind of uses of the technology that show the value, but there's been, you know, comments when we bring up these polls of what do we need to be able to start to get buy-in from decision makers, is more case studies and continuing to be able to show here's how DPS was actually used to help out on these various paving projects. So trying to facilitate more demonstration projects and case studies are what these little sub bullets are here from our last poll. And that also includes the analysis end of things. So I think, you know, what Kurt was alluding to, I think Granite Construction, they incorporated Veda partially because they also had other intelligent construction technologies on those projects, and we're able to get some really meaningful results. So how do we try to take this DPS data collection and continue from an analysis point of view, making it accessible to new users and current users, but also meaningful in terms of the information that it provides. So these are different things we need to continue to improve on as a group. Logistics of data collection sounds simple, but it's a huge factor. And that's something where it goes back to the training that we talked about before. But it can be really overwhelming if you're just getting out there on a construction site and you have this new technology. We need to be set up in a spot where if you don't have a Mercedes who's been out there over and over and over again, people can collect Mercedes type quality data. And so that's kind of the goal with this setting up our logistics of data collection, where new users and experienced users are both achieving quality data when we go out there. Cost benefit evidence, that ties back into the cost of equipment, and that's something we'll evaluate. I think Craig Londefeld did a good job of selling it DPS to his upper management and leadership, just by looking at the road network and the potential cost savings if we are able to extend it. And that's something where maybe the case studies comes in and we'll talk more about that later. Lack of agency use as a quality acceptance tool, and this is maybe a chicken or egg thing where until the agencies use it as an acceptance tool, contractors might not want to use it as a quality management or quality control tool. So that's something that we need to continue address and maybe get a little bit more creative with how we do our pilot implementations and things of that nature. So we'll look into that too with our proposed tasks. We also asked the question, what do you see as an immediate research need to enable DPS implementation? So talking about potential for high-speed data collection in situations where you can wait until construction is done for the day and test it all at once might be something that'll make it more implementable. And then how do we address the challenges both from an environmental and from the logistics of high-speed data collection that might come up that way. So that's something we'll look into. We've talked about calibration of equipment and being able to tell when our calibration from dielectric to density is good or bad, and that comes through the validation cores and how we address that, and then the sensor bias, making sure we have unbiased sensors, things of that nature. Yeah, a lot of these are bullets that came up over and over again. From a research point of view, continuing to build out our appropriate use and setting boundaries of when you should be using DPS and when, if, for example, like that Massachusetts mix where you had a magnetic aggregate, you shouldn't be going out there and expecting DPS to give you density information. So this type of stuff, also I think that the simulation work can help us in that direction too, where we can take our empirical studies that are kind of one single situation and then generalize it and give a quantitative range of appropriate use for DPS. What do you see as a current communication gap need for DPS implementation? So back to the case studies, clear and convincing evidence of benefits. Comprehensive manual, I think somebody called it a little book of DPS last time. Was that you, George? So yeah, and again, going back to determining which projects are right for DPS, where should we initially be implementing it at, get the biggest bang for our buck, so to speak. I was happy to see Brandon Brever was on from the Minnesota Asphalt Paving Association, but there was some comments, and this is a recurring theme of getting more of the Asphalt Pavement Association involvement. And I think the comment was last time that probably less than 5% of contractors even know DPS exists. And how do we kind of build out our communications to make sure people are just up to speed on where we're at with DPS. And then we had, at that point, unanimous vote to continue the pooled fund, which is kind of the reason that's a subject matter for today is, okay, if there's interest in continuing this work and developing a new work plan, let's make sure that we're hitting on the topics that people are most interested in. So we still have 11 minutes, so I'm going to go through some of Irv's workshop results, and you will see a lot of these similar themes that we saw from our pooled fund, even though at this point we had kind of a wider reach at TRB with the workshop. So after Kurt gave his DOT perspective on, this was both on DPS and paver mounted thermal profile, we polled the group and got 58 responses about what would be the best use of DPS and PMTP for your agency or company. And from an agency perspective, use it as a bid item to provide data to support implementation. So basically measuring consistency in real time and keeping the production team aware of their processes in real time. And this is where both with DPS, PMTP, and IC, you know, there's examples that you can point to that say, okay, there's certain processes that are continually, periodically going wrong. And that's happening throughout the country. How do we take this technology and try to eliminate or at least mitigate these processes that are leading to lower density or segregated mix based on the use of these new intelligent construction technologies. From a contractor perspective, used as a QC tool for paving process improvement. So that's kind of nice to see a little bit of overlap there in terms of where they see value. And then, of course, making the real-time process improvement changes. So, and then we also got some comments from people who didn't identify themselves as agency or contractor to use it for quality control were a lot of answers, and then an accurate tool that outperforms current NDT test methods, continuous geolocated pavement data. The next question was, how would you measure success? So of the 58 responses, 9 agency responses related to improved measured pavement quality and consistency. Again, no pun intended, consistent with what we heard with the previous question. And then, of course, from a contractor point of view, if they're going to be achieving more consistent densities and using this as a process control tool to improve their paving, they want to get paid more. And I think that makes sense, because if we're getting longer lasting pavements, you know, it's okay for us to pay for that. And how do we set that up in a way that it sends that type of an incentive structure? So we also had use of DPS and PMTP by myself and Craig Landefeld from Ohio DOT, and a lot of the same themes that I'm not going to go through in detail here, but basically this kind of got into a little bit more of how do we justify the cost of DPS, both in terms of training, cost of equipment, and investing in this technology as a state or as an agency, being able to make the argument that it is going to actually increase the life cycle of our pavements and ultimately sustainability of our road networks. We got a contractor perspective, and as you might expect, how do you sell this to your company? Well, if you're a contractor, show me the money, explain the monetary benefits, and how do we as an agency create incentive structures to allow contractors to make money for building better pavements through this technology. How would you implement the technology from the agencies? You know, each agency needs to kind of have a champion that's pushing this type of technology to be able to get it to the finish line for implementation was one of the themes. And then we also had Jeff Withy from Federal Highway give a presentation, and a lot of that was related to how do we work with the current Code of Federal Regulations to make sure that we're doing this in a way that's appropriate from a federal regulations point of view. Okay. So with that, we also presented this at our most recent technical working group meeting. So we got some good feedback that I wanted to share with the larger group here about especially the things related to our work plan development. So Irv gave the PowerPoint summary that I just gave to everyone, and basically just asked for input from the technical working group. And Brian Diefendorfer talked about one priority being, you know, how can we make this implementable for agencies? And one idea is, instead of doing the data collection as part of the paving train, make it more of a, or at least make an option for a more high-speed collection that that would allow for the logistics of a situation where you might not be able to have somebody there for the entire day, but can provide somebody at the end of the day to do the data collection. So that's one thing we'll look into, including the challenges of high-speed data collection. Rich Giesel had a priority of basically, with the existing technology, what can we do to use this technology in a way that's going to be helpful. Forget about pie in the sky ideas, but we have a technology that can provide useful information. What can we do now? And that's something that Tom, you has kind of echoed in our meetings with Federal Highway, and that's kind of where we're going with our work plan is trying to separate it into tasks that just involve what we have now, the methods we have now, how can it be used to help us improve? And then the other kind of phase of or track that we're going with this work plan are what are the things that we want to still continue to improve to help us in the future. So that was a good comment from Rich. George Chang, right here in the meeting, agreed with Irv. Do you typically agree with Irv on stuff?
Not quite, but.
In this case, you agree with Irv. DPS for high-speed profiling, making that an option would help. And then, of course, continuing to research and perfect the technology to overcome the existing hurdles. And then, of course, improving analysis capabilities, which are there any analysis tools out there that can help with capabilities, George?
I don't know, maybe something like this.
Oh, Veda. So that's one option to be able to take this technology to the next level. Dennis Dvorak from Federal Highway wanted to make sure that we're continuing to involve the vendors and make the technology easier to use to collect data and help states along, which I think, you know, both GSSI and Earth Science Systems and some of the vendors for DPS have been great to work with, and we need to continue to facilitate those relationships. And then training was another theme that kept coming up. Craig Londefeld was talking about the need for pilot projects. You know, just because DPS works well on a certain type of project doesn't mean it's going to work well, and we need to continue to expose it to various pilot projects and just get DPS out there and show the benefits of it, and also at that point use that data to be able to refine the limitations and the strengths of the method itself. Steve Cooper mentioned something that I completely agree with is needing not only just contractor support, but people like Todd Mansell and Caterpillar here, getting support from industry and making sure that we're doing things as a pooled fund that makes sense from a construction company point of view. And then also continuing to invite industry and manufacturers to our user group meetings. They tend to move us towards more practical use of the technology when we involve industry, so we appreciate that. One thing Professor Leva mentioned was, you know, very similar to what we've heard already, exposing contractors as much as possible, providing training, supporting implementation, and then trying to correlate it with our other intelligent construction technologies and leveraging how the equipment is going to work together. And then Mercedes says we need to emphasize training and piloting of DPS, which agrees with some of the comments that we heard before. And I think you just did that in California a couple of weeks ago. So with that, we did have a post TRB meetings bullets that I have 1 minute to go through. So I'm going to do that before I release everyone for a break. But kind of just summarizing things that we've also already talked about. Short-term training needs. This is stuff to support technology as is, but then also long-term training needs, which includes maybe a little bit more on the development end, like developing golden equipment for comparisons, which I think George mentioned was good for the profiling growth. Support system, for implementing DPS, so we'll continue the technical working group, but then also involve kind of sub-users groups to attack specific challenges. And we'll hit on a lot of these items when we start to go through the proposed tasks, and that includes maybe some innovative contractual ways of implementing DPS, as well as of being able to, I guess, one thing I want to highlight with item number 9 before we go to break is, one question to ask with DPS is, does it provide value? And if the answer is yes, how do we get to a point where we're providing value? And one way to put that into perspective is, okay, what are we currently doing if we don't have DPS on the project? And what are the limitations in those situations when you're just coring or just doing a nuclear gauge, and maybe even do a study on kind of what is the risk to an agency with and without DPS, and see where that might land in terms of justifying or promoting the use of DPS on projects. So with that, we are all released for the next 19 minutes, and we'll come back at 10:40 a.m. and dig into the work plan. So thank you.
Hey, everybody, it is 10:40, and that means our break is over. And better late than never, we have located a microphone. So thank you very much, Mercedes, for finding this. And this will be a really big help as we go through the rest of our day. Mercedes has volunteered to run this around to people so that while we're talking, people can hear your important comments. And as we continue on with this part of the day, sorry, it's one of these lapel ones that I'm just having to hold up. So everyone's going to have to do that also. Kyle, anything you want to say as we get going here, or I can just set the table for the rest of the day?
That's a table.
All right, so the easy part is over. And now we all get to do the heavy lifting of really taking a look at a work plan that Kyle and his team have put together, and going through the process of trying to refine it, and more importantly, to build it out and add to it with an eye on what needs to happen from the group's perspective in a second phase, an additional 4 or 5 more years of the DPS pool fund. And the way it's going to work, really, Kyle is going to be going through this plan that he has put together, but listening to this group and adding to that plan, potentially adding tasks to the plan. And then this group is also going to have an opportunity to look at the tasks that have been revised and expanded upon and do some ranking. And this is not any sort of long-term commitment to say, well, the voting today, that's going to be phase 2 of the pool fund, but it is going to be a bit of a straw polling mechanism for this group to see where its priorities are and to go from there to continue to revise those tasks further. The reason I wanted to mention the whole process is because there's a ranking process towards the end. I think it's important not to carve away too much at anything right now to say that's not important. The way you express something isn't important is by giving it a lower ranking rather than by taking things off the table up front. That's just sort of my viewpoint. But if the group agrees, hey, this is outside the scope, we can take it away too. This can unfold in a couple different ways. It depends a bit on whether what Kyle has to show you is close, or whether it's far away, whether it's complete, or whether it needs a lot more additions, and we'll find that out as this discussion gets going. So, Kyle, you're nodding, shrugging.
Yeah.
Are you good to go?
Yeah.
All right, great. I'm gonna hand the mic away. You're gonna share your screen.
All right, thank you, Brian. So, used a lot of big words, like overall themes and vision for the next pooled fund. But basically, I just wanted to, before going into specific proposed tasks, just talk a little bit about kind of how we tried to set up the work plan big picture. So it's a little bit different in the sense that this pooled fund is somewhat of a continuation on the previous pooled fund. And so the question is, how do we want to organize this next work plan so that we're both keeping the momentum going from the current work plan, but then also differentiated in terms of what this pooled fund is trying to accomplish that the other one didn't. And I think you'll see that some of the tasks are a continuation more of what we've been doing and just trying to continue to build out the program. But you'll also see that some of them that we propose are kind of a new direction. And kind of based on the feedback from Tom Yu during some meetings with the Federal Highway, we differentiated these two tracks into kind of an implementation track and research and marketing and communications track. So implementation track, I just put on here to give you a little bit of background on what I mean by that is how can we use DPS technology as is with our current understanding of the strengths and limitations to improve on the status quo and provide value. So it's easy to get bogged down in, well, as long as if we could just collect it at high speed, or if we could just have an equipment that's mounted to a final roll, or who's got their shoes on? All right, so the goal with having an implementation track is that in this case, it's very clear that these are the tasks that with the existing technology, with our current understanding, this is how we think we can provide value. So let's make sure we're doing that in addition to the other track, which is more of our research and marketing and communications, which is more our, it would be nice, or these are things that would be helpful, or all these developmental, sometimes pie in the sky type directions that we want to go as a group, so that we're not just totally focusing on what we have now, but also with our eye to the future of where we want to go with DPS. So that's basically how can we continue to advance the technology and methodology to further refine suggested use and build the program toward full deployment. Because I think certainly currently we can't just take the technology as we understand it right now and say every state needs to put this on every project. So, but there's things we can do to try to move closer to that direction. So what we're going to do now is evaluate some of the proposed tasks and then hopefully develop some new ones. Hopefully you've all been, sorry about that. I use my hands when I talk sometimes. So hopefully you've all been writing down or jotting down notes, or you will jot down some notes and ideas for tasks that you'd like to see done, or ideas that you'd like to see pursued for DPS, so that when we evaluate the proposed tasks, we'll be able to also add some additional ones for evaluation.
Is there a reason why you added marketing communication as part of research?
Yeah, that's a good point. So Steve said, why is there a reason why we have marketing and communications in addition to on the same research track? I guess the way that it's set up is, what are we doing right now with the technology as is, period, and then everything else. So eventually, you know, I think it probably does make more sense to have 3 tracks, but for the purposes of this meeting, I think, you know, let's just go with
Well, to preview 2 minutes into the future, the planning document you have actually breaks them into 3 tracks. So
so I did it by accident. You know what I probably did? This is a great marketing tool that I'm gonna use right now, is that as pavement engineers, we're always doing things just because that's the way that we've always done it. So we have like things that we do just because there's a precedent there. I looked at my agenda when I was putting this thing together, and it showed on there 2 tracks. And we're gonna look at 1 track first and another track second. So then I boxed myself into those 2 tracks, but I could have been like, I think we all should be, and say, okay, can we actually change the way we're doing things for better? So don't be like me, be like Steve, and continue to evolve. So, but with that, there's 2 bullets there, but we will be going through each individual track during the work plan evaluation. So once we get done with looking at the proposed tasks and hopefully developing new ones, we are going to rank kind of where we see the highest priority tasks. And as Brian said, this isn't going to be like some quantitative, these are the tasks we're doing first yet. It's just more getting a straw poll of where we're at as a group. And we might be asking people to identify if they're agency, contractor, I don't know for sure on that, but just try to get some information on where people are at with these various tasks and the importance of them. And I do think we're going to go through all of the tasks and add all of the tasks before we do any polling. Is that right, Brian?
that's right.
Okay. I keep using my hands too much. Okay. So then after that, the goal after this meeting is to take all this information and develop a work plan that can be used to kind of solicit the next phase of the DPS pooled fund. And I was talking to Steve over the break, and I think maybe a goal for this group would be to have something that we can, for those of us who want to continue on the pooled fund, something that we can put in front of people and market at TRB this coming January. So when we have our fall meeting as a group, hopefully we have something that we can put out there to solicit the next phase of the pooled fund. Is that what you were thinking, Steve? Okay. And then of course we want to determine the kind of minimum number of participating members, number of years, overall budget needed to be able to deliver another pooled fund. And maybe we could even talk about a little bit today how the 25,000 per year for contributing members looks, or if we want to increase or decrease that based on participation. And then at the end of the day, reevaluate the work plan with the contributing members and the kickoff meeting. And this is where what Brian said comes into play, where we're not using the results from today as our be all end all. It's going to be the contributing members of the pooled fund who ultimately decide what the work plan looks like. So, and then of course we can adjust the scope of work based on the participation level.
Just a quick note on timing. This pooled fund ends at the end of this calendar year. Is that correct?
Yeah.
You're waiting until TRB to kick off to still get solicitations. You're going to have a gap, which may be okay, but just be aware of that.
Right. Yeah. So if we do wait until the meeting in the fall, we'd have a couple options. One, we would either just have a gap between when the two pooled funds occur, or if there's funding remaining. I believe we have up to 5 years on the current pooled fund, so we could potentially extend the current pooled fund to facilitate technical working group meetings to continue, and then a large group meeting. Yeah, but that's good context. So Yeah, because it does take time between when we develop our work plan and when we actually get it posted and get it approved and get the wheels in motion. So with that, I think we're gonna evaluate the proposed tasks next. Oh, yeah, and Brian's gonna share his screen. Your screen. Hard to tell. Yeah, I'm sharing my screen now. No.
There we go.
Okay, so we're not gonna get bogged down in the title or anything like that. I think what we'll do here is scroll down to where the proposed tasks are. And I'll just briefly go over some of them. So we're gonna start with the research track, which is again, tasks geared toward advancing the method, technology, and understanding to improve feasibility and functionality of DPS. So task R&D 1 was basically it's proposed to be using field, lab, and then potentially some of the simulation that Hang presented earlier today to do some research of the critical factors to develop kind of best and worst use conditions for DPS. So subtask 1A would be identifying the most critical technical factors affecting use of dielectric for density assessment. So this could be looking more into if there's a density gradient in a lift, how is that going to affect our DPS results or surface characteristics? If there's a segregated mix, how is that going to affect our correlation with density? Continuing to look into possible causes of difference between our gyratory calibrations and our field validations. Moisture, especially if we look into the high-speed approach or the day after approach, there can be conditions, whether it's an overnight rain or if there's dew in the morning. We need to continue to keep moisture in mind as we're developing our proposed protocols. And then some of the stuff that Hang presented with really defining the specimen size that's appropriate for our gyratory compaction calibrations, looking at the effect of gradation or max rock size, and that could be both experimental or simulation in terms of looking at the Raleigh wave or the Raleigh scattering of our DPS sensors. But then ultimately, after we identify these critical factors, we need to be able to both design models, whether that's GPR max, like what Hang presented, or in some cases, laboratory or field experiments. Sometimes it's just more appropriate to actually just do the measurements and see what the results are, either in the field or in a laboratory environment. If we do go with the simulation. Yeah. Yeah. So then if we do go with the modeling approach, we obviously need to design experiments to validate those models. So if we're going to generalize, for example, our specimen size that's appropriate, we need to validate that those results are appropriate with some benchmark experimental cases. We'll also want to expand the findings. So when we generalize or we create these generalized models, we need to be able to expand what we've actually measured and generalize it so that we can give appropriate boundary conditions for successful use of DPS. And then when we expand the models, of course, you still have to validate with experimental tests and then ultimately full scale on paving projects. And then at the end of the day, with tasks like this, I think our ultimate goal is to be able to develop and kind of house a list of these are the conditions and parameters that are conducive to successful use of DPS. And these are a list of conditions that make DPS not an appropriate tool. And I think that'll do a few things for us. I think a lot of times with the paving industry, correct me if I'm wrong, but different states, they just don't do certain things because they had a bad experience. So that could be when you first start doing anything, if you don't have a good experience originally, it basically gets mothballed and that specific state just doesn't do that. And I think the goal with this research should be, let's give some really good guidance on what are the conditions where we expect good results with DPS, and what are the conditions where we are telling you ahead of time, don't apply it on this situation where you have a ½ inch of asphalt on top of concrete, for example, or some of these situations where a state is going to have a bad experience with it. Let's get that documented after we do our experiments and modeling. So at the end of each of these tasks, I put just a little write-up of kind of, if I had trouble figuring out what's the purpose of the task, then I eliminated the task. So, which I don't know if that makes sense, but I feel like there should be a purpose to what we're doing, right, Todd?
Right.
Okay, good. So, and Irv says for 1A, any item that needs to be kept in mind is how the effects can be used for troubleshooting. Yeah, thanks for the comment, Irv. And good to see you joined us. I didn't know you were on. So the purpose of this one is ensure proper understanding of critical factors affecting DPS use to better inform proper implementation of the technology. You know, who would be involved with this? I think, you know, consultants, federal or state agencies, you know, especially with what Hang presented in Turner Fairbank, I think would be something that we'd want to look into continuing on the next phase of the pool fund. And then, of course, universities, research centers, etc. How it can be marketed as the importance of this task is we want to help our members avoid headaches of improper use. So we don't want to be that group that says, oh, I should have known I shouldn't have used it in this situation. It's not the nuts and bolts of it. So I think Brian, what do you think? Should we continue to go through, or should we take comments after?
My thoughts are, anyone among you may think there are some things that need to be added to this that may actually be an additional task altogether. So maybe to just go through, I believe you have 4 R&D tasks.
Yeah.
Is that right? To maybe step through those 4.
Okay.
And before moving on to the other ones, then it's a chance for people to see what's missing from here. Does it need to be added as a subtask to an existing one, or does it need to be added as a 5th or a 6th task among these? So that would be, I think, a reasonable way to do it.
All right, let's do that. So the next proposed task is to evaluate the feasibility of improvement in data collection methods. So just a little bit of background, the way we're currently collecting data, regardless of the vendor, is basically a push cart system where you either have a person walking or segueing behind the equipment. And we've looked into various ways of collecting it with a vehicle and trying to go back and forth with a vehicle going at higher speeds in the past. And at that point, just the increased pure accuracy of knowing where the sensors are, for one, but then also the data density that you get from going at a walking speed, in addition to the real-time feedback of being on the construction site during the paving process, has led us to focus on that as our current way of doing data collection. There's been comments about how nice it would be to be able to just take this technology and wait till the end of the day and then just test it all. And one way to do that would be to start to look again at higher speed data collection methods. And I think, you know, that investigation would have to include not just the precision effect on a lower density data or something of the antenna and all that stuff, but also looking into, okay, if we had a high speed solution, when would it be applied? And if that answer is the next morning, we need to be looking into, okay, how is moisture on the pavement from a rain event overnight or things of that nature going to be either addressed or spent out in terms of that type of deployment. Maybe just even a survey of agencies or contractors, if a high-speed option was available, how would you deploy it? How much would that help in your implementation efforts if that option was developed further from a research point of view? Subtask R&D 2B would be it. I think everybody in this room would probably prefer to be able to take the equipment and just have it go right behind the rolling, the final roller compactor and give you full coverage measurements all in one pass. And the current technology is somewhere between 1 and 3 sensors if you have just one piece of equipment. So I think this task would involve, okay, what type of strategy could we take to being able to get full coverage measurements all in one pass? So, you know, one contractor that we're talking to for this construction season was like, well, what if I took 2 pieces of equipment, put it on a vehicle and stiffened it up so that we didn't have any sag and just got 6 sensor passes and for a full coverage measurement on a fully closed project at the end of the day. And I think if we can get some results about successes and failures of that type of an approach, maybe this would be something we'd further research or even if you look into subtask R&D 2C, maybe solicit proposals to take our existing technology and make it work in a solution for a single pass full coverage solution. So in this case, we'd be moving more towards where we want to be, I think, as a group, in terms of just saying, hey, this is the data we want. This is what's giving us the geospatial maps we want. This is giving us the percent within limits information we want, and take some of the analyses that UNH is going to be doing as part of this pooled fund with our current data and say, this is acceptable data, industry, contractors, consultants, propose a solution to get us that data and maybe drive.
In theory, the finished roller is covering the entire mat, right? So if they can solve the moisture issue off the back end, I know some of them have tried, right? But if you solve the moisture issue and combine it with intelligent compaction where they're seeing, or pass count technology where they're seeing, making sure you've got kind of a solution. And then from lane closure, there's other benefits.
Yeah, I think so what Robert brought up about having sensors actually on the roller compactors, challenges of moisture, challenges of vibration, benefit of actually having live maps of what is the improvement in density with each pass, but also creates an additional challenge of, if we're going to use this as our final assessment, being able to say, I'm just taking that last measurement from after the final pass. But these are exactly the type of kind of innovations that we'd be looking at, is in terms of both, does it still give us quality data, and is it more implementable? If Caterpillar can just put it on a roller compactor, does that become something that makes more sense business wise for you guys? I don't know. So.
Is the intent of this next build fund to look at it from a QA standpoint, or are we still focused on both QC and QA?
Yes.
The only reason I ask is, I don't know my lack of knowledge in this space, but from a QC standpoint, I don't know how much further we really need to take it, right? The technology's out there, use it how you wish, get a better end product, but at the end of the day, we're still gonna go measure it with cores in a new cage. But if we focus on the QA side, in terms of here's how we're gonna incentivize you for it, here's how we're gonna regulate it, all of that side of it, to me, that seems like where all the value is in terms of bringing this to the next level or the next progression. Because then it gets into the why, right? If you take a step all the way back and say, like you were talking earlier, this is a great shiny object.
Yeah.
But what is the true value of it?
Yeah.
And then from there, you start looking at comparing it to traditional methods. Yes, you can take it to 100% map of density, which is awesome. But do you need to take it that far to get? It's probably not linear in terms of how much you're mapping versus the life expectancy you're getting out of it. You're measuring today, maybe 1% if you're lucky of the road, not even. If you go to 10%, does that give you 80% confidence in your life expectancy? And maybe you have that in here, but I think it's a really important part.
Yeah.
Of implementing it as a QA tool.
I don't know if you want to put it
I
in.
don't think it's part of this.
It might not fit. It's kind of in the research side, but it's the why of.
Yes.
What do we want to get out of it?
In somewhere when we get.
Right, and I think where it does kind of fit is, you know, to answer your question on what works as full coverage. That's, we're looking as a quality assurance type, you know.
Yeah. That's like the ultimate goal,
Yes,
right? But
yes.
maybe something less is.
Yeah, or if you talk to Matt Oman at Matthews, you know, he might tell you, okay, if I'm just looking at it purely from a QC point of view, do a couple transverse passes and see if there's somewhere in my rolling train that we're missing in the transverse direction, or, you know, so somehow need to address where this stuff is geared towards quality assurance and where it's geared towards, well, that's a good thing.
But in terms of full coverage, we don't necessarily have to cover the whole project. So maybe select a few sections to cover that section of full coverage. Yeah, 500 feet full coverage, right? And then check the.
That's hard to do it in a section of the project, because it always ends up that the sections we really want data for, there's nothing collected from. So I'd rather look at what you're saying, Brian, is how much is needed of the spread. You know, we do want more than 3 sensors probably across, you know, like what everybody's saying, but I think you're right, you have different users, the contractors are gonna do some quick spot tests out there, with vacuum cleaners, you know, right?
Yeah.
And then, you know, the states will wanna do quick tests, because not everybody can do a nuclear gauge out there, right?
Yeah.
But we probably just do spot tests, you know, here and there, on the agency side. But then for deployment, the states are all over the board nationally who would do the final QA. Minnesota, we would have the contractor do the final pass. There's never gonna be buy-in to have to do it throughout the day. They're gonna wanna do one pass at the end of the day and get it all done, because that's a lot of expenses, having an employee standing out there waiting, behind the finishing roller, waiting for the water to evaporate to do a pass. You know, that's a lot of manpower that you barely keep continuity of staffing already, so. So I think you hit it, Brian, is you need multiple uses of it, you know, and who do you want to focus on, you know, right? Contractor or the agency, you know, right? Of the needs of the measurements, different uses of it. And the final QA, it'll be different people doing the final QA. It'll either be a contractor for some states could be the agency.
Right.
Doing it, so that's gonna vary too, and I would assume most agencies, all of us, we can barely have enough inspectors out there already, and then to expect them to know how to run this, you know, you can't have somebody following. We don't even have people, that's the reason about intelligent action thermal profile, we don't have people out there to be able to stand and watch the operation, so there's no way on the state side, the states are gonna be able to have an employee out there following them.
Right.
That's why we're getting rid of tickets too. We don't want somebody safety, right?
Yeah.
Somebody's standing there by the truck grabbing paper tickets, so I don't know, just all things to think about.
Yep, yep, and those things, I think. You know,
I'm already typing into your next task because it seems like
yeah,
this comes into the cost benefit.
yeah,
Or benefit, yeah.
yeah,
So when the Sharp 2 research ended, we had one antenna.
Yeah.
Hardware, software, one antenna. Say, well, we'd like to cover a wider area. Can we go expand that a little bit, but still keep it at reasonable cost?
right,
That's basically, let's see if we can get 3 antennas software to cover. That's what got us into the $70,000.
right,
So it's set up for. You got one sensor, GSI is up to 3 sensors. Try to cover the full pavement width. You know, right now the technology's not set up for that, but you're still adding, that's gonna be a 3 to 4 year effort.
yeah,
Because it's just not, the technology's not there. So do you really need it?
yeah. Well, I think, you know,
We're on a roll right now with maximum 3 engines.
right, right.
I try to maximize it.
Right, and we're starting with the research track, you know, so we're on the, you know, these are things that, like Rebecca was saying. From a full deployment point of view. It's tough to see the 3 sensor walk behind system being a full deployment solution. So I think it's appropriate to still have some of these 3 or 4 year efforts, or even potentially 10-year efforts on the list of potential topics, and ultimately decide the highest priority ones, because there are potentially some benefits in looking into and getting data towards, okay, what would it look like if a contractor took 6 sensors with 2 systems and got us full coverage data at the end of each day? That kind of thing, I think, would be the intent of.
Pushing someone like a 3D radar.
Or yes, or
You know, has the capability.
yeah, yeah, yeah,
Not Todd with Caterpillar. That's,
Yeah.
and that's the whole challenge with this, you know,
Yeah.
we're figuring out if and how well the technology works, but at the same time, when we have the spec coming in, I mean, at the end of the day, the two are evolving together.
right,
You've got a spec you want to get out there, but are you going to bring a spec out that says 6 sensors and 100% coverage? I'm going to argue that's going to fall in its face, right?
Yeah,
Like, you know,
right,
so the spec has to
right,
come out initially with the existing technology, if you will, and what works, like you were just talking about.
Right.
And that's gonna evolve over time.
right.
As we learn more of it.
And that kind of a perspective is something we are thinking about even in the implementation track, where these pilot projects, if it's a one-time thing where you have buy-in from a contractor and you're testing things out, potentially you go with the 6 sensor pass, versus if it's something that, you know, you're trying to do on a routine basis. Let's take what we have now and say, how do we provide value? Maybe it's not perfect, but how do we take what we have now and provide value? So Brian's been adding some notes in here, which is good.
I'm scooping you because you haven't gone through this task yet. But it seemed like this was more
Yeah,
fit in with number 3.
yes, yes. Can't, well,
Well, I
can't,
don't know.
we'll put it there for now.
Yeah, we
Put
can
it
move
there.
it.
That's fine. So let's go back
Yeah.
to task 2. And
We've gotten to C.
yeah. And so now we're on subtask R&D 2D. So this would be further investigate the possibility of using robotic data collection. And just background on this, we rightfully, as a DPS group, rejected doing robots as part of our DPS pooled fund, just because it was anticipated that this isn't something that as a national group, it's gonna be ready to be used, but at the same time, MnDOT pursued robotic application, and then also the GSSI has looked into a little bit of robotic applications. So the question here is, are we to a point as a DPS user group, because of the constraints that we're in right now in terms of not wanting to have personnel dedicated throughout the entire day to collection behind the final roller pass, and not necessarily being in a place where we can just say, yeah, let's do high-speed data collection at the end of the day. Do we want to potentially further investigate the use of robotic data? And the current solution we're looking into is using the alignment file, but ultimately we'd want the robots to be doing their pathing based on the as-built information. So that would be another thing that would have to be kept in mind if we pursue this as a group. And actually, I consider not even putting it in here, other than I don't know if there's a potential, if we're doing robotic or automated data collection, if that would put us in a place where we could get funding from kind of innovative funds. And I know maybe Steve, not to put you on the spot, but is there some initiatives on the federal highway end that would support that kind of activities if we had any interest in it? Or
Yeah, I don't know. I mean, one option is you put it out there as one of our demonstrations. Is anybody willing to trial GSSI's robot?
Yeah.
See how that goes. Because I saw it last fall, but I don't know where it stands. Just
right.
does it actually work?
Yeah, I think in this situation, the UMN solution would be somebody who could propose on what we're trying to do. I think what we would end up doing in this kind of a situation is say, similar to what we would say with the data collection spec for contractors and consultants in industry, where we just say, this is what the robot needs to do for data collection, and see what options are out there. And of course, UMN could propose on it, and GSSI's robot could propose on it. I think the cost of that would be probably more than what we want to take on as a pooled fund group, but I just didn't know if there's kind of some innovative funding type to support, if it's something that's helping with worker safety and those.
So I have some ideas, but I need to vet them before I speak on it. So I
okay.
Get in trouble if I don't vet those ideas first. Make sure that they're
right. So yeah, so I basically put that on as a place.
One time, I think some people mentioned about 20 million.
Okay.
Highway innovation funds. So the state has to apply for that, right?
Yeah.
So maybe
That's
we can use part of
closed.
that for in pool funds.
Okay. Brian's sweating over here about me not getting through, but
Well, I think first thing with this topic is we have to decide as, at least as public agencies, do we even want to go down that road, or we just want to say, you know, right now we're getting 3 up, 3 down, 3 up, and that's probably more than we need.
yeah,
If someone wants 2 up, 2 down, 2 up, is that enough? If 6 lines of data down the road is enough, then we just say, we want 6 lines of data down the road, and the problem goes away. It lands in the people who can fix it.
Yeah.
We aren't the people who can fix this.
right. So that would kind of go into subtask 2 C. Basically say, this is the data that we need. Make up. Yeah.
So I don't know where it fits in here, but I mean, as part of this group, I mean, do we come up with a draft specification for implementation? Like something, at least on something to start on, because I think that gives us a little more guidance on.
Yeah.
Like to Kurt's point. and
Yeah.
Brian mentioned.
And you might put something in there that is somewhat generic, like enter, the
Right,
state
yeah.
specifies how
Yes.
many passes to perform rather than say X many passes.
Well, no, we don't, for thermal, we say we want this many dots. And right now, we've got people who are giving us a lot more than that many dots because the equipment they bought and the spec is written around the old thermal bar. Now, we could change that and make it a lot, we could crank, and we have done a little bit of that, cranking up some of the requirements, but that's, chicken and the egg. You can't write a spec for something that doesn't exist, but if we write a spec and we tell people this is what we want to exist,
They better do
they
it.
will build it.
Okay.
The money will come. So that's rather than, let's figure out what it is we want and somebody will build it.
Yeah.
I think this question is, this will respond to the question people ask, can we increase the data acquisition speed? Have a high speed data acquisition, which means takes less time
Yeah.
to get the data. That's what.
Yeah.
Idea is how you increase the speed.
Okay, so I have a proposal. I'm gonna listen to Brian and get through. Yeah.
I'm worried that people are proposing stuff that's coming, and
Yeah.
I think Kyle needs to, people didn't see this in advance, right?
Correct.
Okay, you need to get through this so they know what you're, and then you can see, hey, it's there, no, it's not.
Yeah, all right, let's do it. So I'm not gonna be as long-winded as I normally am. So we are on.
That was the end of the elder.
Brian, you wanted to drive though. Yeah, that's true. I did. I asked for that too. Okay, I said it was spicy. All right. So we are on to task 3, proposed task 3. Cost benefit analysis by quantifying various DPS factors. So the way I broke this down is how to, different ways that we can justify states or agencies investing in this type of technology. So subtask 3A was more focused on, looking at what are we doing now and what is the risk and uncertainty associated with business as usual, and compare that to if we had DPS, paper mounted thermal profile, intelligent compaction, e-ticketing, all giving us, full coverage or continuous measurements. What is the risk mitigation that we get from an agency point of view compared to what we have now? Not perfection, what we have now. We have an added task there based on the discussion from Brian. 3B was evaluating and quantifying the effect on potential cost savings through longer lasting pavements. So for this to work, we need to have some assumptions based on, well, what kind of improvements in density are realistic to assume if we implement DPS. And I think that's something where maybe we just throw a few case studies and saying, this is an example.
Just to go along with it, I took a note. I was thinking it might be helpful to develop a form that outlines for all these case studies.
Yeah.
That includes aspects for cost benefit, kind of like without any changes related to DPS production.
To kind of help people report out.
Yes, and then also if there's a way to quantify for contractors too, right? So that you get both agency and contractor benefits captured in these case studies in a typical format that then when everyone's comparing it.
Yes.
They're able to say, hey, look, we've got now a lot of data over these benefits.
Right. Yep. So.
Jacob.
Yep.
So I know you talked to Capri.
Yes.
Just recently, our research roadmap subcommittee, meeting.
Yeah.
But, Griffin Sullivan from Mississippi, and I are gonna be kind of contacts for this DPS pool fund for Capri.
Yeah.
And maybe ways that Capri can help. Some of the stuff that's going on here. This may be a task
That would fit in with that subgroup with Capri.
possibly.
Okay. Yeah, no, that makes sense. So So the idea would be basically we have to have at least some inputs showing, yes, DPS can improve or has potential to improve our density, and what does that mean in terms of the life of that road? And then based on each state's road network, I think we can come up with some justifiable big numbers for cost savings caused by DPS. And I think, you know, part of this is it's marketing. It's basically saying, assuming all this is true, but I do think that's important for leadership to get on board, to be able to have some of these big numbers of potential cost savings from implementing DPS. So that would be the focus of that subtask.
And Kyle, real quick,
Yeah.
some of the DPS agencies that don't, they have one shot with upper management.
Yeah.
So that would be crucial.
Okay. Okay, so Jacob's gonna rank that one high. So so now we're going to, I think we could also take a look at it from an improved safety aspect, but I do think that one would need to be a projection based on possible collection strategies, not current collection strategies, because if we're gonna have a person out there pushing a cart, I don't know if that's a direction we want to go as a safety improvement, but at the same time, if we're able to, and Rick Bradbury said, can we try to capture actual cost of density pay reductions and replace from agencies? Yeah, so that's another aspect to go, not just the extended payment life, but trying to mitigate the number of remove and replaces that we have by finding these problem processes. Be able to quantify the effect of reducing coring. So we're talking about limiting the amount of coring that we're taking. That's also not just a safety issue, but you're cutting holes in your pavement. So do we want to include that in our justification or cost justification analysis? So gonna go past the purpose of marketing.
Be quiet.
That was my goal, but yeah.
So with that last one, Greg had made a good comment over here and stuff too. We have to tie it to the other technologies as well, because that's the importance of the front end. You're doing an after measurement, right? And
Yeah.
so you talk about the effects of density on long-term performance, and there's tons of studies on that. So I assume this will be a huge literature search.
Yeah.
There's an NHI course on it where they have pretty much every study summarized super powerfully.
Yeah.
The effects of density, ergonomics, permeability, all that stuff on long-term pavement performance. So
Yeah.
it's all there, it's documented, but it's really, you know, the transparency, it's providing that education of the cost benefit of why you need the other technologies, because this is after the fact. So as Kurt said, the thermal, you know, the paper's already gone through with segregation of mix and placement. My goodness, you guys have done great presentations, Todd, on, you know, material segregation from the pavers and all this other stuff. You have the rollers coming through with this compaction. That's the cost benefit is that, you know, the additional thing, because there's so many variables coming into play that affect density, and this is just the final number of it. And so I do think with that task that you guys need to be integrating the other technologies into it as well, because this is, you know, right?
Yes.
Pretty
Yeah.
much, you know, it's after the fact, it's all the workmanship that's done before, and you're just measuring what happened out there. So it's not curing it, you know, right? The placement, the construction, and everything before it is the curing. You're telling them you screwed up after the fact, you know, right? You screwed up, this is what you're doing. You might be able to fix it for the next day and stuff, or later in the day, but it's not, you know, they do have real-time tools, and so we need to connect them to those real-time tools. You have these real-time tools. We're seeing this with the DPS. You've had slides on it, even Kyle, you know,
Yeah.
where we share data and everything, and you know, this is what you need to fix up.
Right.
See what you're doing with the floors. We can see what you're doing with your paver. Big stragging underneath here. You have all this other stuff. So that would need to be tied into there. It just can't be straight. Yeah.
I think that's a good comment. So, and we could maybe even do a tiered type analysis of, you know, DPS or DPS with other tools and the iterative approach of saying, hey, this is a problem that we're seeing periodically. What is the iterative process of diagnosing how to actually make a correction? And that would include other ICT technologies. So good comment. All right, so R&D number 4, advanced analysis development. So this kind of ties in a little bit with the reporting that we talked about earlier, but basically we're collecting all this data with DPS. How do we get it in the hands of the people who can actually change the processes that are causing good or bad density out there? So with this task, I think, you know, it could be for 3A, looking at kind of simple things that are basically saying, when you see something with DPS data, let the foreman know, because a lot of times they can look at their process and make decisions to figure out why certain things are happening out in the field. Or we could get into subtask R&D 3B, which is how do we leverage data fusion of, we have our map with DPS data, but we also have all these other process maps. How do we kind of improve this iterative process so when we do see issues, they're fixed the same day or the next day, not looked at 2 weeks after the project's done where you can't do anything. So that would be kind of the focus for 3B. 3C would be basically any sort of software improvements for the on-site or third-party post-processing like Veda that we would want to see as a group that could help us get that more timely feedback. 3D would be kind of more looking outside of the pavement construction community. So this could include maybe doing some artificial intelligence, machine learning type expertise, getting them involved, where we say, these are all of our geospatial maps with intelligent construction technologies. Help us build an instrument that'll tell us what the most critical factors are with our process and how we can refine those processes. And again, this is on the research track, so this is more building towards the future. Let's keep going. So now we're in marketing and communications, and I think for this, it's a lot of it would be similar to what we're already doing with this pooled fund. It's basically taking what we learn and having meetings like this, having technical working group meetings, building out user groups. So I think, Brian, we can just go through these and just basically say, the first one is involving support communication. The second one is continued training and technical assistance. And then the third one is continued promotion of the technology. So implementation track. So this is where we were kind of going with a lot of the comments from before. So we want to make sure we're addressing those here. So these are tasks focused on implementing what we have now with only minor refinements, if any. So 1.1 is building up a DPS user group for expanded demonstrations and pilot projects. So one feedback we've been getting is that it's difficult to have personnel with expertise to be able to go out and collect quality data on a continuous basis, and then also be able to sustain that level of personnel to be applied for DPS. So I think the different subtasks here are one, update and package our training materials that we've developed as part of this pooled fund, and as much as possible, get them simplified to a point where a new user could get up to speed quicker, which is one way to help address this issue. Conduct live training events as the methods are refined. One thing that is not part of our current pooled fund that I think would be useful is developing and certifying regional expertise. So basically, if a state gets interested in DPS, has some success, how do we keep that momentum going where they can say, you know what, I don't have somebody I can assign to these projects, but I want to do them. And so in this case, the goal would be to get hireable TPS data collection and analysis, and that most likely would be consultants who are able to be, have a specific rate that says, okay, let's hire from our consultant list company XYZ to come out and collect this data for us, but we want them to be trained and available to collect good data. And then we want to maintain that list and maybe basically keep it up to date so that when people are in need of getting quality data collection done, there's a group of people who could be hired and expected to get good data. So task implementation 2 is to update our AASHTO specifications and then also our protocols. So kind of what Todd was saying, where we have our current AASHTO specifications more for this is the right type of equipment, if it can do X, Y, and Z, and this is the type of laboratory procedure you can follow to get dielectric measurements of gyratory compacted samples. But let's also continue to build these protocols that you could give to a state and say, okay, here's the bare bones, here's the skeleton of what you need to implement this, and then each state could modify it to fit whatever their specific needs are. And this is maybe something that we can kind of look at further refining, so we don't need to go into too much detail. I guess I do want to talk about implementation 2E, which is looking maybe at more innovative implementation strategies. So instead of trying to fit DPS in a core quality assurance box, let's look a little bit outside the box and how we're going to get this technology out there and provide value. So one thing would be to, one option could be use it for QC only, but there could be action requirements to improve the quality and no disincentives. I don't know if that's something that would be more palatable for some states to implement, or could be items for QA that is withholding payment if the data just isn't collected. And that's something that I know, MnDOT has done in the past, which is basically saying, let's pay for the data to be collected, and the payment is based on, did you actually collect the data we asked you to collect? And yeah, maybe we don't need to go into too much detail on that. I just wanted to note that that's in there. We want to support national pilot project and GHOST implementations. And here's where I think one of these subtasks kind of hits on what Robert was talking about, where we want to determine, or we want to develop a template and facilitate report out of successes, barriers, and ideas for improved use of DPS on each pilot project. And maybe Brian, just add on there and template for reporting out cost benefit analysis, or items that may be used in a cost benefit analysis. Yes. And then now we're on task I4, which is certification center development. And this is something that I think George Chang was talking about before with the profiler, in terms of being able to take the equipment, especially as new vendors come onto the scene, and say, okay, as long as you're certified by this procedure, we can trust your equipment on our project. So this would be building on the work that NCAT did and try to modify our current specification for as the technology is changing. So for example, we were using swerve test and repeat line type analysis for this in the past. Now, maybe we can get away with just using fiberglass block and just do more of a standardized material that way, which I think also mirrors more what is done with the profiler. So, and also we want to include something that continues to evaluate the effectiveness of the DPS equipment. So it's not just it passed at the beginning of the year and now all of a sudden it's not working at the end of the year. We still need to have our daily evaluations and validations of the data as we get it out there. And this could also be deployed in online or in-person certification implementations. So we need to keep that in mind. And then always make sure that this is updated based on our field trials. So it needs to stay current and up to date with what we're actually doing in the field. So I think I might have made it through, Brian.
You did, and it's always challenging to tell a group, we want your comments,
Which is
but hold your comments. Well, if you've been holding them, hold them no longer, because this is a chance, if there's something that's missing, if there's something that really should be broken into multiple things, we're gonna be having a ranking exercise on all three of these categories where everyone in the room will have a chance to rank them in importance. So if it gets too granular, it's really, we can't rank 20 things. I think that won't make any sense. So right now it is pretty much the 4, the 3, and the 3, but enough of me talking. What else do people have to say in it? I don't mind bouncing around between areas and tasks.
Okay, yeah, go ahead, Todd.
Oh, well, one of the ones I know I got up was 3B. It was one of the talking about linking, I think, the DPS data with other ICT technologies.
Yeah.
Yeah. So, and back to, what Rebecca was mentioning as well, and that I almost think that comes down to having that data real time. And I don't know how we do that.
Yeah.
But I think that's really what that subtask is asking. And maybe I'm wrong, but
yeah.
But
no, I agree.
But if we're going to use it to improve the process in the field.
I was going to ask, what does CAP want?
We need
real-time data.
We need a real time, like just, like thermal or IC.
Yeah.
I mean, and it's not that we can't still correlate it and use it that way. But.
So from a state and it's George at that.
Yeah.
That George.
My fault. From a state and agency standpoint, if you had a full density map of the road, do you care about thermal and mapping?
Oh, yeah.
Why?
Because like Rebecca was saying before, that's telling us when there's issues, we know what's causing it. And I think it's one of those things where I think in addition to the things that we already know about, but being able to monitor them and correct them as quickly as possible, if we're able to hit what Todd is saying in terms of getting it out there real time, I would suspect that there's a lot of things that we just have no idea, but are really important.
For sure, yeah.
Right now.
Yeah.
And so but the analogy difference for me would be like, you can look at your granular film from like high school when they're telling you what you screwed up, and this is going back to high school, what you screwed up on when you're trying to play pre-safety in high school versus like when you go to college. Now all of a sudden they have every play broken down for you and they're telling you exactly where you screwed up. Yeah. You're going to fix that a lot quicker, with this type of full coverage, not just with the end result, but the process,
So what I'm thinking is from a state and an agency standpoint, the end goal is, we'll call it meeting density over the entire road. Yeah. Today, we only know here and there based on cores and nuke. Yeah. So we're saying we want all the other information to help paint a better picture of, do we think even though we only saw a couple cores, do we think it's representative of the whole road?
Yeah.
With this technology, now we know the whole road. So from like a payout standpoint, you could turn off all the payouts on thermo and IC. Yes, it's something that the contractor is going to want to have still available and improve their process. But at the end of the day, I feel like this is sort of replacing from the state and agency standpoint, because it does give you it could give you 100% confidence in what you're getting.
It does, as long as everything's passed.
Correct. Correct.
Because we've already done this with cores. We've had projects where we had good cores and bad cores, and we were able to locate them and say, oh yeah, the the breakdown roller missed those spots.
Yep. Yep.
And we were able to tell the contractor, you're not gonna go out there and do that again tomorrow,
Yeah.
because we, not only are you failing, we know how and why you're failing.
Yep.
And they were then stuck going, well, geez, they know how to fix me, I better fix myself.
So do you want to, so I'm not saying we should get rid of any of that. Do you want to put the burden or shift the burden some to more towards the contractor, because now you have the ability to get a clearer picture of what you're getting?
That's ideal, but.
Because isn't
Yeah,
that
there,
why?
there are some contractors now who aren't looking at the data they've been collecting for the last 8 years.
Absolutely. That's what I'm kind of getting at is those things are all great tools, but that's probably one of the biggest roadblocks for contractors or other states going after it is they don't have the people to analyze and go after it. But
I think it also comes down a little bit to what we were talking about before, whether it's more research or implementation focused, because like right now in New York, we're very much focused on the implementation side. Sorry. Brendan Rock from New York. Like I was saying, we're much more focused on the implementation side because we don't really use, thermal bar maps, data, we're very much in the mode of, we've got 4 measurements now, having 100,000 measurements is way better than what we're doing right now. So we're very much focused on the implementation side of it. And I think I would definitely echo your points. For sure, we're looking at how we can use all this data and really statistically boil it down to how we pay.
I'm gonna, Rick Bradbury with Maine had his hand up online. Rick, did you still have a comment you'd like to make?
Yeah, I just wanted to point out that, this discussion of if we have pole coverage with rolling density meter, is thermal still important? The thermal profilers measure a lot more than just surface temp. They measure paver speed, they measure location and duration of paver stops. Those things directly impact smoothness as well as density. I would hate to see contractors move away from collecting thermal data and all the benefit we can get from that, just because we're covering the entire map with rolling density meters, so we somehow think we don't need the thermal data.
Thanks a lot, Rick. I'm just gonna repeat what you said. Tell me if I said it wrong, because it was a little bit spotty with the connection, but one thing that you wouldn't like to see is the information from something like a paver mounted thermal profile, like paver speed, and things that don't necessarily affect just density go away based on whatever we're trying to market as part of the pooled fund. Is that right?
Yes, that's correct. Thank you.
This is Matt. I just jumped on a little while ago. Matt Oman, that is, with Matthew. A big difference that I just heard on this piece of whether it was covered or not, sorry about that, but with the paver mounted thermal data, that is, as real time as you can get. And so there you could start making, adjustments to your process just from looking at the screen or whether you're logged in. So that's, to me, that's a difference with the rolling density meter being, behind the cold roller to catch the finish. You're kind of chasing behind it. So the MOBA system is, basically as real time as you can get.
Thanks, Matt.
Kyle, Jake Walker, GDOT. I think what, I don't know if this needs to be part of the next pool fund or this could be something down a bit. We're collecting all this data, and I think that kind of go along, I guess, maybe with what Rebecca saying. Looking at it from like a bigger picture point of view, where, down the road, we're getting, I think states in general are looking more and more into them and some of these technologies and linking the technologies and make it more like a full circle with digital as-bills and maybe digital delivery and that kind of thing. I think there's agencies, I know our agencies are talking. So having all this data that, down the road, 10 or 15 years when a payment management group is putting together a payment evaluation where they can look at some of this construction data and they're seeing cracking in the road, but then they can look and say, okay, well, here we had, the benefit of looking at this data down the road using data would be very, but looking and seeing where, okay, there's a lot of cracking here, but this is more on construction, and it's even with doing less core in the future. I think there's a lot of benefit down the road. I don't know if that's something we can do analysis for. I don't know if we've had the data long enough to really analyze, but I think it's something that down the road could possibly be looked into, that the benefit of all collecting this information for just I guess been down the road.
Bryce? Mercedes is in charge.
So I've been on 6 demos with the pave scan already this year, states, contractors, and every single one of them has been, I don't have the employees to do this. We just don't have, I can't even hire a QC technician to run samples for me. How am I gonna find somebody to do this? That's been pretty much every single one of these years. So I think we should keep that in mind. I don't think it's a trend that's not, there's more and more jobs. I think it's over 500,000 right now that need to be fulfilled in this industry, and it's increasing, not decreasing. So making that process as frictionless as possible with putting it on equipment that's already running stuff is, I think ultimately determine the success of this. Because contractors are going to fight this hard with not being able to have the people that even run it. And I'm seeing that a lot right now.
I would agree with that. You also, on the agency side, SR issues. So I was just saying, like, we're seeing the same issues, and from the agency side, if we want to specify this, there's just not really a way I can currently roll this equipment out to every region of New York State. So we're looking at it from contractor collected, like you were saying, it's already on equipment out there. That's ideal. So I think a big task that we're starting to look into is the data validation from the agency side, so we can use all the data that's collected for an acceptance. So how we're going to validate data is going to be a huge point for us.
So Brendan, you've done a good job in New York of getting a consultant up to speed. And I'm just curious if you have any thoughts on strategies for building out kind of a larger network of consultants who are able to fill a need. Any thoughts on that?
So the way we did it was to just put it into contracts. So contracts are available, as someone did before. Contracts are available, people send. So we're doing it as all shadow, just, the first version of the spec was half a page. It's collect it and let us see it.
Yeah.
It's valuable. And it's 4 years on at this point, we're 3 pages and a materials method.
Yeah.
So as someone said before, this continues to develop. So the way we did it is just put it into contracts, and someone will fill that role.
Yeah.
As we get bigger and bigger, more and more people say, okay, this is something they're continuing to look at. It's not gone.
Yeah.
So more people will come on. That's been successful for us. We're really lucky that we have a few of these available in our state.
Yeah.
On the contracting side as well as testing firm side.
Yeah.
Without that, I don't see how we'd be able to develop this.
Yeah.
It does raise the other issue as we get closer to some kind of acceptance method. The flip side of that is we're going to have to validate this something that's acceptable to everyone involved.
Right.
George Chen with Transit Group. In 2018, after many years of implementation of IC and PMTP, Federal Highway started looking into data QA. So what's missing here is the CFR compliant data QA.
Yeah.
And then MINDA and MODA, we have spent about 3-4 years to develop a data QA just for thermal.
Yeah.
This will be needed for states like you hire Richard Hamilton to do all these data collection for you, but you still need to do that 10% 15% data.
random
QA.
sampling.
Yeah. CFR compliant data QA.
Throwing it up there as an implementation task.
So
Okay, and then Rich concurred, correlation and validation will be required.
right, and during that meeting, 2018 meeting, I think we have a slide from Rebecca. That show the 3 requirements that need to comply. One is the device need to be certified or validated before. And then secondly, the data transmission for the device to the eventual analysis cannot be tampered.
Yeah.
And the third is the analysis, you have to be comply with the whatever the filtering. So 3 steps, data valid, transmission is secure, and finally correct analysis result and send it to you, pass or fail, right?
Yeah.
One of the requirements for the data transmission is you cannot use Excel spreadsheet. Kyle?
Yeah.
Second step.
Yeah.
In that meeting is we cannot use Excel spreadsheet because once you have into a CSV file, it can be tampered.
Yeah.
Yeah, so
Needs
that's
to be a
basically
binary file.
it could be a binary file or the best is direct from the machine to the cloud directly to the analysis software. That's what we've been doing ever since 2018.
Yeah. Thanks, George. Yeah. Yeah, and that'll be involved certainly in the specifications and innovative, program.
So we were just talking before about, we're different in that we don't do volumetrics every lot. So I would be curious, and maybe be something to be voted on if you're the whole group look into it, but states that don't do volumetrics, how often does we need to calibrate to things? Frequency of calibration to it be of interest.
Yeah. And yeah.
I'm Todd here with Kat. I guess I'm maybe jumping around. But I think one of the things was we heard earlier from Heng and Joe, I think both brought up the 4-inch calibration seems to be pretty accurate or good.
Yeah.
But 90, 80, I'd argue, I'm just picking a number, but probably 80 or 90% of all the pavements we put down are less than 4 inches thick. So how does that factor in to the?
Okay. Clarification. So the measurements that Hang and Joe were talking about.
Yeah.
Gyratory compacted.
Oh, okay.
Samples.
Not field.
Not field, yeah. So the field samples would be a surface reflection.
Oh, okay.
Measurement out on the pavement.
Okay.
So, yeah.
Which is
Thank you.
The gyratory compacted samples.
No, field.
Yeah,
2 inches, right?
for a surface reflection, we're looking at about a 2-inch area of influence, and it's mostly in the top inch. So,
So that went right over my head.
well, I mean, it's been a fire hose of information going on, so.
Okay, good.
Okay, so. I think, do we need to vote before we eat, or can we eat?
People are talking to, I think we should eat.
Okay, so here's your incentive structure. If you're open to a working lunch, Brian's gonna let us eat now. But if you're not, we gotta vote first, so.
We vote for a working lunch, yes.
All right, working lunch, okay. So get your food, come back to your spot, and then we'll do a little bit more work. Yeah.
It seems to be a working lunch that is so far mostly lunch, but we're gonna.
Oh, it's fine.
We're gonna do a little work, but not a lot of work, but really important work. Okay, and before we get to pulling up our online polling, just wanted to. As you've seen, I've been making some changes in track changes mode to this document as we've been going along, trying to reflect comments as best as possible. A few things have been added to this list since as actual additional tasks. And I believe they're both in the R&D area. And you can see on the screen, the first of these is effective uses of dielectric data without need of converting to density. This is done a little bit more in shorthand than the other ones that were more fully developed, but just to give a sense, using dielectric to make variability assessments, to make process control decisions, and to identify deficient areas as 3 possible examples. An additional task that was added was innovative solutions due to labor supply shortages. Looking at things like innovative contracting, innovative processes, and also changing how this technology is used in order to deal with this problem that we've heard voiced by a number of people. Again, we captured some other tweaks throughout. I want to just confirm as I scroll through this, I don't believe we've added any additional tasks to the other 2 areas, and that's correct. We started adding here and we ended up not doing that. So it's just going to be the other tasks as drafted with some changes made. So with that,
I think, well,
go ahead.
yeah, I would. I guess before we move to anything else, we're gonna be voting on tasks, not subtasks. So if there's any, there was a lot of good comments early on that I'm not sure I'm sure Katie captured them, but that's not gonna show up on our polling. So if either there's a task idea that we didn't cover with our current tasks, or if there was a subtask that you thought was so important, you wanted to at least get us to vote on that specifically as an individual task, I think now would be the time to propose something to actually get a straw poll vote on from the group.
Consider I don't remember what all was with the robotic subtasks. And what the other subtasks that were with that task. That was that one I could see being divisive. Possibly, and I would hate to see if there's anything else in that task. Considered if people don't want to vote for the robotic.
Yeah, okay, so we could either just full out eliminate the robotic as a subtask or a task, unless somebody in here really wants to pursue robots. Okay. Hey, we got Steve Cooper.
There was a comment about the innovative contracting, right?
Yeah.
For labor. I think it's really more innovative. Appointment. Contract. In which case they can use robots.
Right.
Approaches.
Right.
But that's what we want to see.
Okay. All right, so correct me if I'm paraphrasing wrong, is that basically, even if we eliminate robots as a subtask, there's nothing stopping contractors or consultants from using robots. If we say, hey, this is the data you need to collect. So Brian, I would propose eliminating which task was that?
I think it was 2D.
Yeah, so if you're voting for task 2, that doesn't mean you're trying to fund robots. It's that's eliminated from that task.
Good comment.
Thanks, Jacob. Any other tasks that you'd like to get some feedback on?
It's MTU, from Michigan Tech. I just realized this is my first time to attend this work group. I really learned a lot of things. I have a question, before we vote. So there are, a lot of good tasks need to be done. One thing I'm not sure, what's the limit, or maybe what's the scope of the pavement types or materials? I heard something saying, if you have concrete pavements and on top you have asphalt, right? That's something, maybe a special note should be there. And then my question is, what if about say you have some, let's say, a dense graded mix or versus more porous mix? Is that something that need to be done somewhere, or maybe it's done already? And of course, that's the one question. Another thing is, what about some other materials? Like I heard somebody mention about some of the aggregates in Massachusetts, right? Maybe have some more of other magnetic type of minerals there. And that's probably, of course, like Minnesota, maybe there are some kind of aggregates have a lot of high iron content. And or in Michigan, there are maybe some aggregates have other kind of minerals. I don't know if those things are going to impact the results. And also I mentioned this to some of you. Now I'm doing some work, not only for, in rubber asphalt we use quite a bit in Michigan. And also recently we are also allowing you to use recycled glass. So those things could play, some kind of impact. I would say there should be some impact on the when we use DPS. So just wonder if those things are going to be in those consideration, or that already have been done or considered already. All right, that's all I have.
Great. Okay. So I guess one question for the group, do we want to include that as a separate task, or do we want to just assume that that is a subtask in our field lab simulation research of critical factors to develop best and worst use conditions for DPS?
It fits in that.
It fits in that. So just as a group, then we know that what Professor just brought up is included in our current subtask R&D 1.
You
That
gotta have
one-
your students work on it, right?
Yes. We always say yes, right?
Okay, any other tasks up for?
And this may already be included as well. I know.
Yeah.
And we talked about it on the research end, was the different aggregate sizes in the mix. So 3/4 inch mix, 1/2 inch. But I did notice that all the fine aggregate was grouped from, I don't know if it was number 4 sieve or the number 8 down.
Okay.
And I'm just purely bringing it up as, is that something we need to look at more? And I'm thinking from my QC days, like if you got a lot of dust or -200s in the mix, that would totally throw off your field densities.
So maybe, yeah.
Well, hopefully they're capturing that in their GMM.
Right.
prices that they're running.
Right.
Right. And
So I don't
binder
know.
content.
I'm just kind of throwing it out there.
Gradation and,
Yeah,
yeah,
I don't know if that's something you need to.
yeah,
look
I
at
think
closer.
certainly included in that subtask. Well, and that's the other thing, right? Well, yeah, is there a set of, okay, invoice? $0, okay, we're good.
I wanted to share a thought, and that is, we're doing some voting on some pretty coarse tasks that have a lot of subtasks. Whichever one rises to the top, we might do a quick poll on the subtasks.
Yeah.
And so this happens to be one that people are most interested in. We can also do a thing on A through E under 1 to see.
Yeah.
If this is an example. Yeah. In the next 25 minutes here. Yeah.
Yeah. Pretty good.
So high level, can we show the
Yeah.
the 4?
Yeah, good idea. Okay, so let's start with,
Well, should we actually want to do the? I'm sorry, could you finish your question?
No. We can probably just show the poll and actually do it.
Okay.
okay, but
I'm thinking about something more than in my mind, just wrapping it around the
the high level topics.
Okay,
We can probably just vote and start there. Okay, thank you.
okay, because my only question is, would it be helpful in determining if there's something that's not covered, if we just very quickly just read the title of each of the tasks we're gonna vote on? And then if you're like, whoa, this is not covered, then now's your time. So I'm just gonna read them. Yes, okay, so field/lab/simulation research of critical factors to develop best and worst use conditions for DPS. Next. Evaluate feasibility of improvement in data collection methods. Not necessarily robots there. Okay. Task R&D3, cost benefit analysis by quantifying various DPS factors. Advanced analysis development. And we added effective uses of dielectric data without need of converting to density. That would be designed to address issues with situations like what Jacob brought up about not having volumetric samples to test. Innovative solutions due to labor supply shortages. And then marketing and communications, we're going to support communication. Continued training and technical assistant. Continued promotion of the technology. And implementation track, build DPS user group for expanded demonstrations and pilot projects. Update AASHTO specifications and GHOST implementation pilot protocols. Support national pilot project GHOST implementations. Certification center development. That's it. So after reading those off,
Just curious, for the two primary tasks. Are we gonna try to separate, say, the communication marketing ones from?
yes,
Okay.
initially, yeah. Right, we're gonna vote just on research, just on
Yeah, okay, I just wanted to.
implementation. I don't even think we'll vote on marketing unless we find a need, but we'll see. Okay. So did that list generally cover most of the important ideas that you guys had in mind? Okay. Let's vote.
Great. And do you have a poll up that we can visually see each one all together?
All right.
Brian's gonna cover that, I think so, but I don't want to speak.
Well, let's, if we could, thank you. These instructions are for everyone online and everyone in the room. If you could please go to the website menti.com on your phone or on your computer, and that's spelled MENTI.com. And then you should see on the screen, there is a 8-digit code. 737722264. And once you're there, if you hit that thumbs up, it lets me know that people are arriving, and I see 6 talented, 9, 10 talented people have done that. And we're in the double digits. Please, everyone online and everyone in the room.
All right,
Hitting it.
semi-talented.
Over and over and over.
Yeah.
But your number does, the number doesn't go up, but you just get a lot of thumbs. Great, we're in the 30s now, which is excellent.
Wow.
34 people.
Like stuff in the ballot, you just keep hitting the button over.
Just like Allie.
If somebody invited all their friends and all their company picnic, this is an activity.
The number goes above the number of participants we have, Brian, we gotta.
I'm using all 5 of them. Should I step out for this?
And even when we move through these slides, there will be the ability to get back onto these, so I think we're kind of stuck at 38, let's.
Dominion is not involved.
Dominion is not.
Everybody aware of that.
We were having such a friendly meeting. All right, let's move to the next slide here. And this is a little small on the screen, but it should be perfectly well sized on your
interface, whether you're on the computer or on your phone, you're being asked to rank the importance and kind of take that as you wish. I'm really viewing this as what you would like to see the focus of the next phase of the pool fund.
And if you need a refresher on any of these titles, I'll take a guess and try to remember what I put on there.
Just a clarification. First is is as you expect would be of the most importance to you.
Advanced analysis development.
That one included okay. Todd was asking about advanced analysis development.
Question.
Yeah, if I remember, that includes being able to package what you're getting on real time, on site. In the information that can be used in the field, and then it also involved improving how we package DPS data with other ICT technologies, again, to get information quicker.
So, okay.
Yeah.
Thanks. So some of that's combined, seems like it'd be combined with the innovative solutions to labor shortages, right?
That is a good point. Yeah, so, and maybe this is one of those things, who's it? Is it Iowa who does it, where you gotta get your top 3 or so, and then you've got to vote again, and maybe we can do something like that, or how long would that you can do, Brian?
Well, again, I think a big piece might be, and it looks like R&D 1 is coming in top. We might want to do a voting on our task 1 subtasks. Just to really see what is for on the. Well, we're at 31 now, and people are still voting. Let's give it another.
Theoretically, there could be a split vote between RND 6 and RND 4. Causing it to be lower, but could be. Was this tracked? How many votes are in?
It's in the lower right.
Yeah.
It shows how many.
38 people.
Yeah. We're just, I think 39 total.
Okay.
Gave us a thumbs up, so we're good. I'd like to do this for presentation. It's also. Yes. Kyle, you think that?
Yeah, oh, you brought that.
Oh.
You share with everyone. It's like, I didn't see that.
All right, we're at 39 voters, and I'm just gonna, I think everyone can hopefully see well enough or remember, but that's really tiny, so that we're voting 40 voters, which is great. The task 1 on the research of critical factors for best in use conditions came in first there, followed by the evaluating the feasibility of improvement and data collection. And then in third was the cost benefit analysis of quantifying various DPS factors. Kyle did mention that the final 2 items, there might have been enough overlap between task 6, which came in 5th place, innovative solutions to labor shortages, and task 4, advanced analysis development. But again, that's okay, because we can continue to analyze these things, I think, but this gives an idea of where things are. Go ahead.
I have a proposal that might evaluate your ability to work on the fly, Brian, but does anybody else in the group see a value if we just did a quick importance of each one individually? Very important, not important.
So a rating rather than a ranking.
Yeah, in this case, they're not necessarily pitted against each other, and how close they are to other ones doesn't affect it as much, or I'm open to not doing it.
I think it's super worthwhile. Yeah, I think you would gain a lot of knowledge from that.
Okay.
Yeah.
Okay, so Brian's gonna set up that Well, do we want to be voting on the implementation ones, ranking the implementation ones while you're building that?
I don't think that will be possible, but just.
You can't do
I can
that.
this quickly.
He's gonna do this quickly. Yeah.
We did.
Does anybody want to make an impassioned speech or against any of these tasks? All right.
You should be able to rate these all on a 5-point rating scale. Assume 5 is of highest importance and 1 is of lowest importance.
Go ahead and stump.
So Brian Nagel with Caterpillar. I think it's gonna fall within the top 3, but the cost benefit analysis, without understanding that, this whole thing is sunk in almost every aspect, right? If we're gonna get anyone to invest in it, whether it's at any of the different levels, if we can't quantify and truly understand that, it's difficult to know how much a contractor should spend on a system that's different. How do we incentivize all of those things? So like I said, I think it's gonna fall within the top 3, but it's definitely a very important part of the picture.
Okay, and that's something that Jacob also commented on about. Sometimes you just have one opportunity to sell why we should get into DPS or not, and that might help.
Okay, and like this, you should have done this from the beginning. Ratings.
It just came right to my brain.
Yeah.
It's hard for me, I just rank them all high.
Yeah, but it's PowerPoint.
This might give us the same exact results that we just got.
But in a way more useful way.
Okay, there we go.
More quantifiable.
There we go.
So that we understand the difference between.
And they theoretically could have all been ones. That's good.
That's right.
Then we would have gone home.
Yeah, I'm not sure anyone would beat their here if they're wrong.
I just did the Minnesota thing and put 3 for all.
There you go. Would you like to do this? How that would get.
Yeah.
Neutral, okay. All right.
Stepping in.
Yeah, Brian, you must not be a real Minnesotan to go out on a limb there. So unless there's dissent, we're gonna do that second form for rating for the implementation as well. And I really appreciate you guys staying for a working lunch, because it's gonna get us all out of here earlier, and I think we'll be more these results are more energized than they would have been if we would have had to like come back from lunch and do it, so.
Or no lunch.
Or no lunch, that would have been the worst. That would have been all lunch. So Mimi, are you going to invite us all out to San Jose? Is that the?
Well, no, the next project, so remember, it's gonna be in October, but it'll be in Martinez, but more by the bridge in the bay. So
Okay.
you're all invited.
So maybe that's the next meeting location.
And I'll write a really good article.
Voting is open for the last one.
Okay. This is a horse race here.
It is. Oh.
Oh,
Photo finish. Oh. We all look in sports.
We'll put money on the next one.
Is this how we're determining funding for each
No,
state?
Straw poll, it's just.
It's just, hey, if you feel really strong, you have to pitch in more, you just.
my answer.
That number 42 is where we are. Okay.
I lost.
Would you like to pull anything else while the group is on their menus? If you'd like to look at any of the projects in more granular detail.
I would ask the group, is there any specific polling question? Could be anything you want that you want us to do. It could be subtasks for one of the higher ranked.
I think it'd be helpful to see the subtabs.
So poll the subtasks,
At least the top three.
okay,
Maybe work.
okay. So let's pull, I think research task one. Some of them are designed to build on top of each other, so it might not make too much sense, but.
I think research test one in particular.
Okay.
Is the one we started.
Okay.
Okay.
What's the code, Brian?
I'm getting it right back in the screen right now.
Oh, okay.
Yeah, thanks.
Yeah.
Yeah, no. There in a second.
It's kind of booted yeah. For the last votes.
Oh, yeah, mine does. I got booted too.
All right, yeah, because it was at the end, so you're gonna have to. Again, it's menti.com and then the code is at the top of the screen.
Anybody in the back need help reading off that code?
But the code is same like last
Yeah.
one?
Yeah.
It is, but since we were on the last slide, it exited everybody.
Well, that's, they're willing to just be blind with their clip,
This is,
so,
this is much harder.
yeah.
I feel like I'm gonna fail this. year.
Yeah, Craig, let's read Craig's comment. No, just wait.
Throw the dart.
You don't remember all these?
Yeah. Like 1D, use calibrate model to
So-
exceed binding wider.
Those have to do with the GPR max. I think those,
Yeah, that was you.
one B through E, I think have to do with the GPR max.
You know, I certainly.
Yeah,
You can
we could pull up
put this
the,
up while people are voting.
pull up the subtask write-ups. It's hard because some of them build on top of each other, but. Yeah, so 1B would be, I'll talk about it in terms of example. So it's hard. So it's a little bit difficult because all these tasks kind of build on top of each other. So I'll do it in terms of an example. So one example, we wanted to look into the effect of max rock size on our DPS results. So in task 1B, we would want to design a model to see how the wave interacts with inclusions, i.e. aggregates in a heterogeneous mixture. But then we also need to have laboratory experiments and field trials to say, okay, according to the model, once we get up to a 3/4 inch max aggregate, this affects our signal uncertainty at a certain level. Well, let's actually do an empirical study out in the field to see if it is actually.
I see why you said this is probably a useless exercise. It's
Yeah.
all intertwined.
Yes, right.
So theoretically, you should have the same numbers.
Kind of, yeah,
Tempted to get your hands on that.
right, right.
Well, in the spirit of a useless exercise, we are gonna look at. We gotta look at the results. We got results now, but maybe that's our lesson to not try this with any other subtests.
I think the others didn't build on them the same way. So
But I think,
Yeah, but I think from that perspective, yeah, we judged correctly because some of these you couldn't even do if you didn't do 1A first, so we appropriately judged that as the highest one. So give yourselves all a hand and it is.
Or to use. It doesn't matter.
Yeah, that's right, that's right. Kurt did all three, so. It is 12:58, so we have 2 minutes left. If, Brian made a really good stump speech on something before the first poll. Does anybody want the floor for the last 2 minutes?
are we gonna do a filibuster for the next 14 hours?
No, we're gonna dismiss at 1 PM. So, or earlier, if there's nothing anybody else wants to say. Well, I
Talk
was,
about we're talking about the next user group meeting.
yeah,
So can you talk about what your game plan is for the rest of the year?
yeah. So Steve and I were talking over the break, and we always have a meeting in October, November, or actually it might have went into December last year to do our work plan, kind of report out on where we're at with the program, and then peer exchange. And I think this year the strategy is going to be to do that like we normally do. So report out on all our data collection from 2023 and analysis with DPS, but then try to time it up so that we're going to be meeting at the same time as another pooled fund that's looking into stripping detection in asphalt pavements with 3D radar as well as other tools. And there's going to be some overlap. There doesn't need to be between the different groups, but we just think it's a good idea to try to do this on the same time where we do our typical day to day and a half with DPS, and then do similar with the other pooled fund study. And then the other thing, depending on how early we do it, we might be able to get some vendors out here with technology and do maybe some demonstrations or show off kind of the current technologies too, in conjunction with that. So there'll be more to come on that. And I don't know if there's anything else you wanted to add, Steve. Okay, all right. That was our 2 minutes. Oh, Jacob's keeping us late. Write that down, David. Oh, George is here until 5 there.
I do have a question. I may as well talk a little bit about before with this pool fund scheduled to end in the year. I know just from George's perspective, pool funds get voted on by our research committees in the fall. So I guess what will we know about a game plan of extension versus when a new pool fund will start?
Yeah. That's a good question. So I think what we'll try to do, it was good that we worked from a document today, because I think hopefully in the next few weeks, we'll be able to get kind of, we can call it a draft future work plan, because I'm assuming, and maybe other states can speak up, what you need when you go to those meetings is not final solicitation necessarily. You just need, this is what is valuable to the state of Georgia. These are the tasks, and then, this is why it's important to us.
Yeah.
So if we sent a $1 a month. So maybe that's gonna have to be done over email, but my inclination would be to keep it at 25,000 per year. Unless there are any feedback on dollar amounts per year that would make sense to the different states. Do you have any thoughts on that?
Higher you go, the less
Right. Right. Do you think 25K is difficult to push?
I don't think so. It seems like that's one.
Okay. Okay.
And that's fine.
All right.
We can extend the current pool fund for another year, we can extend to 5 years. So they can, you collect the 4th year, right? We collect the 3rd year funds, we have the 4th year, 5th year, you can request for 2 year pool funds to join the pool. And give us some time here to Yeah,
Yes.
but we need another new profile.
Okay.
Something.
Yep. Is there discussion?
Yep. All right, well, thank you very much to everybody. Thank you especially to Ryan for doing the polls on the fly and keeping us in check. And all the lively discussion. I had no doubts about you guys, but you came through again, so thank you for that.